Hello, hello, hello. Good morning, my lovely warriors. Are you all able to see me and hear me loud and clear? Hello, Tarun. Hello, Harita. Welcome, welcome, Bhumi. Hello, Roshni. Hello, Jagdish. Hello, Akila. Muthu, welcome aboard. And good morning, lovely morning out here, because we had an amazing marathon session yesterday, a 5-hour plus marathon for the entire NCERT plus assertion reason plus your case studies. So many case studies, so many assertion reasons. I'm pretty sure now you are gaining little bit of confidence. And those of you who are new, this is a marathon series. In case you have missed the first class, you can definitely watch it even after today's session. And today's session we are going to focus, like the title says, the formula revision with application. Now this is very important. Application. How do you use the formula? So many questions just planned right for you. And those of you who do not know me, this is Shreyas here, your physics master teacher, your captain, and you are my lovely warriors. And yes, already students are saying, let's rock today's session. Very good, Jania, you got that confidence. Hi Marcus, good morning. Thank you Reshma for that lovely heart. Hi Afifa, hi Janani, hello Yachika. Shriya Kumari, nice to see you back. Hi Srinu, hi Tejaswini. Hello Reshma. Good morning, my lovely warriors. So, those of you who want to get in touch with me, they were asking, sir, how do I get in touch with you? I want to talk to you. Well, that's my Instagram handle. That's how you get in touch with me. I might take some time, but yes, I will eventually get back to you. So, welcome aboard. Ready to rock today's session, and a big thanks to all of you for hitting the subscribe button, and a lot of thanks for also smashing the like button. And yesterday's session, we have already crossed 1K likes. I'm so thankful, so grateful to all my lovely warriors. So keep this josh high and make sure that you keep spreading this love, keep spreading the channel's name. Make sure you make us proud no matter where you are, because you are a true Vedan who respects all the teachers, who respects all the institutions, and you are right over here to rock today's session because you have faith in us and you want to score full marks, and we won't let that down. All right, so no matter what is your preparation level, this session is just for you. So let's get started, my 12th standard warriors. Yep, Jania, yes, very true. Good morning, Uncharted. Hello, Kushi. All right, welcome aboard. Hi, Shika. Okay, so this will be in English. This entire session will be in English. So let's begin. And what I'm going to do, I'll give you a brief overview. Chapter, formula. Okay, so what are we going to do? What is the flow of the session? For example, we pick up, let's say, chapter 1. Chapter 1, we are going to revise the formulas first. And once we see the formulas, etc., and then what diagrams or whatever important graphs, all of that, then we are going to go to the application part. In the application part, we are going to see lot of questions. So these questions will be basically MCQs. So lots and lots of MCQs just for you. And then after this is over, then again we'll go to chapter number 2. So that's what is going to happen, and the same process is going to repeat for all the chapters. So this will be a long session, but might not be as long as yesterday's session. Alright, so let's begin the first chapter. You don't have to open NCERT. All I need is your rough sheet. Everybody has the rough sheets? No, this is not going to be a Menti quiz. Everybody has the rough sheets. So I'm expecting around 3 hours, maximum 4 hours. Okay, so that's how it will be. Okay, very good, excellent. So let's begin with our formula revision session, and lots of formulas coming with the application just for all of you so that you rock the term 1 examination. So let's start doing this in the chapter of electric charges and fields. So let's see what are the important formulas and what are the important things that you need to keep in mind. So first let's talk about the charge. So regarding charge, you need to know the properties, like first of all, the charge is conserved in isolated system. isolated system. So basically, if you have one body and if you have another body, this is, let's say for example before, and let's say you have another body here, another body here. This has a charge of +2, this has a charge of, let's say, I don't know, +7. So maybe they interact with each other. Let's say this gets a charge of +4. Okay, this gets a charge of +4. So then remember the total charge is 2 plus 7, which is 9. So if this is 4, this must be +5. So that's charge conservation. Next thing is basically your quantization. So remember, all the charges are in general integral multiples of E. This is the smallest quanta. This is called as the quanta of charge. N is basically any integer. Okay, and the value of E, we all know, is 1.6 into 10 to the power minus 19 coulomb. Keep all these things in mind. Okay, perfect. Charge is obviously scalar quantity, unit of charge everybody knows. Great. Then let's go ahead. Apart from this, okay, then how do charges interact with each other? They apply forces, and that electrostatic force is given by Coulomb's law. So Coulomb's law out there, okay, so Coulomb's law, fair enough. And in Coulomb's law, if you have two charges Q1 and Q2 separated by some distance of r, then the force between them, the force of interaction between them is given by 1 by 4 pi epsilon naught Q1 Q2 by r square. Okay, oops, let me just put it properly, Q1 Q2 by r square. This constant over here, this is your Coulomb constant. Okay, Coulomb constant, and that value is 9 into 10 to the power 9. You're supposed to remember it. Epsilon naught is basically your permittivity of vacuum, and the value is 8.85 into 10 to the power minus 12. Now this is scalar form. You should also remember the vector form of the equation. The vector form of the equation will be same thing, 1 upon 4 pi epsilon naught Q1 Q2 divided by r square, but here you can have a r hat. That r hat is the position vector. So for example, this r is the distance. The r vector, if it is like this, if r vector, the position vector of second particle with respect to the first particle, for example, then the force on it will be in the direction of r hat. R hat is nothing but a small unit vector. A small unit vector in this direction. Now you will be like, sir, the force can be this way or that way also. You don't have to worry about it. Q1, Q2 will automatically take care of the signs. You can see, if both the charges are positive or both are negative, the product will be positive, correct? So this entire term over here will be positive. So the force will be in the direction of R, in the direction of the position vector. If one of them is negative, one of them is positive, then automatically this will become negative. So the force will automatically come to the other side. Everybody got it? All right, chalo. So if this much is understood, next pointer that you should remember is basically superposition. Superposition, and this is just related to the vector addition of forces. That means if you have multiple charges, let's say 1, 2, 3 and 4, you want to find the force on 3. What you need to do is, due to 1 there will be some force F1, due to 2 there will be some force, let's say F2, due to 4 there will be some force F4. So the vector addition of all of them will give you the net force. So the net force is nothing but the vector addition, F1 bar plus F2 bar plus F3 bar and whatever. Okay, or whatever, sorry, this is F4 bar, F4 bar. Okay, so this is vector addition. That's what something you should keep in mind. Very good, very good. So my god, Divyajot fully binged watched my Pathfinder series. Now your data is off and Wi-Fi is dead. Very good. So please recharge your data packs. You're going to need it a lot because of the marathon sessions. All right, but I'm so glad that you finished your data pack for noble causes. Okay, so if you want, you can take a screenshot of it. It's up to you. But if you're practicing with me, then it's fine. That will be in fact even better. So you can take screenshots once I finish writing this. All right, so I hope you have taken the screenshots. Moving ahead to the next part, but let me also tell you, even if you miss taking the screenshot, you can pause the video even in a live class or even in a recorded class. Not just that, You can also go back even in a live class and catch up at 2x speed if needed, but most likely it will not be. Alright, so Logesh, like I said, this session will be at least 2-3 hours. Okay, next thing that we are going to talk about is field. Okay, so yes, so let's talk about field over here. Okay, so electric field. Just like two charges have force, a charge Q around it creates a field. So if you are at a distance r, then the electric field at that point is given by, again, 1 by 4 pi epsilon naught, you can call it K, into Q by r square. In vector form, you can write it as E is equal to, again, 1 by 4 pi epsilon naught Q by r square into, again, r hat. What is r hat? R hat is nothing but a unit vector in the direction of the position vector. So this is the position where you want to find the field. Okay, now if you are wondering again, what about the direction? Is field always outwards? No. So if you have a positive charge, then the field is always outwards. But if it is a negative charge, then the field is going to terminate on the negative charge. This is one way of writing field, but there is another way of writing field, and that is via force. So again, if you want to define field, this is how you can define field. So if you have Q and at this point you place something called as a test charge, and the test charge is Q, which is tending to 0. So that means it's a very, very small test charge. Then the field at that point, then the field at any point is generally defined like this: limit Q tends to 0, and this is force by Q. Force by Q. So force acting per unit test charge is called as the field. That's the true definition of field, but this is due to a point charge. So this is field due to a point charge. This is field due to a point charge. Whereas this is in general definition of field. Keep this in mind. Now looking at this, you can quickly understand what should be the unit of field. Force by charge. That means it is Newton per Coulomb. Okay, Newton per Coulomb is the unit of field. Very good. Yes, we are going to talk about all the terms. Yes, Komal, don't worry. In terms of V, in terms of U, how is it related with V? Yes, we are going to look at all the formulas. Have patience. Yes, we are going to come to that. Yep, we are going to come to that. And yes, there is another unit of field, and that is volt per meter. You will understand why it is volt per meter in a bit. Just hold on for that. Okay. Having said that, remember electric field lines. Okay, the density decides whether the field is strong or weak. Here the field is weak, and here the field is basically strong. Not just that, if you have a conductor, then the field lines are always perpendicular to the surface of the conductor, and inside the field is 0. Now, even if this conductor has some cavity, it's okay. Even inside that cavity, the field will be 0, because the charges only reside on the surface of a conductor. In fact, there is a formula for the field on the surface of a conductor. So the electric field just outside, okay, just outside the surface of the conductor is given by sigma by epsilon naught. If you are wondering what that sigma is, this sigma is surface charge density, surface charge per unit area. So surface charge per unit area, it's not divided by 2, it is just sigma by epsilon naught. Keep this in mind. Okay, fair enough. Awesome. I'm just going to reduce the brightness a little bit, probably that will help. See if this works. Is this brightness better? Okay, so that is what surface charge density is. All right, very good, very good, very good. Chalo, let's get moving to the next one. Okay, so you can take a screenshot if you want till this point, and then I'm going to move ahead. Okay, yes, all right. Sir, will the PDF be available in the Telegram group? Well, Priya, let me warn you that the PDF will be available, but only for the problems. Whatever I write on the screen, that won't be available, because that gets erased on Google Slides. So when you use Google Slides, there is no such option. Technically, it does not permit us only to, whatever we write to keep it as it is. Okay, Suhani, I'll come to that. Sigma by 2 epsilon naught कैसे होता है और कैसे याद रखना है, I will tell you about it. Don't worry, okay? Just hold on for a bit. Now, see, once we have talked about field, let me also add some more formulas for field. Okay, see, if you have a charge, and let's say you have some external field, this is some external field, then that charge will experience force. The force experienced by it is charge into the field. Now, if the charge is positive, then force is in the direction of the field, but if it is negative, then the force is opposite to the direction of the field. And there are many questions like that. So let's say, for example, the charge has some mass, then you can find out the acceleration like this, because the force is mass into acceleration and the force is charge into field. So therefore you can get acceleration is equal to charge into field divided by mass. So this helps you for solving problems. Once you get acceleration, you can use kinetics and you can solve the questions like S is ut plus half at square, V is u plus at. You can use that because you have just found out the acceleration. Fair enough. Now the next thing that, don't worry, we are going to come to the application part, Harshita, because now I'm just revising the formulas. You'll understand how to use the formulas once we start solving the problems. And meanwhile, I'm also explaining the nitty-gritties and what are the important things that you should keep around that formula while I am showing you all these things. Okay, so pay attention. Okay, now that this is done, all right, the next thing is from field we go to flux. So for example, you have field lines like this and they are cutting through some area. Let's say this is some area through which they are cutting through. That area is basically A, this is the field, then there is some flux associated with it. Now what is flux? Flux is basically flow, and when I say electric flux, it means flow of electric field lines. So the symbol for flux is phi, and because it is electric flux, we put a symbol or subscript like E over there, and this is directly proportional to the number of lines, the field lines that cut through an area. So what it means is that imagine if you have an area like this, and let's say, for example, the field lines pass this way, then if it is moving parallel to the area, is it cutting through the area? No. So in this case, the flux cutting through it is zero. The flux cuts through it only when it pierces that area. So if you had field lines which is like this, then the flux is not zero. So if the flux is at an angle and you can split, or rather the field is at an angle and you can split the field into two components, perpendicular and parallel, only the field lines which are cutting through the area contribute in the flux. The field lines which are parallel to the surface, they do not contribute. Hence the definition of flux formula wise is, electric field dot area vector. If you are wondering what is that area vector is basically the normal, the perpendicular drawn to the surface. So if you draw perpendicular to the surface, so for example, this is a book and I draw a perpendicular, so this is my area vector. Field might be at some other angle. So field can pass through any angle, but area vector is always perpendicular to the surface area. Keep this in mind. But if it is curved, okay, this is for flat surfaces, flat and uniform scenarios. But let's say, for example, if it is curved, then you use integration or summation. So it will be E dot dA. When will you use this? This is used for non-uniform. This is used for non-uniform or basically curved surfaces. Meaning your surface itself is curved like this. This is your curved surface. And the field lines, one is here, one is there, one is here. So essentially you divide the surface into small areas. So this is a small area. So this will have a small unit vector dA. The flux through it will be E dot dA. Field at that point into area at that point. summation is nothing but integration. That will give you the total flux over there. Is that understood, everybody, till this point? Yep. Is that clear, everyone? Very good, very good, very good. Excellent. Cool. Yep. Let's get moving to the next one. Sir, EA cos theta. Well, this is dot product. What is dot product? It is cos. So when you have dot product, if you put in magnitude terms, it will become EA into cos of theta. What is theta? Theta is the angle between them. Theta is the angle between them. Okay, cool. Chalo, let's get moving to the next part quickly. All right. Chalo, let's see some more formulas and then we are almost there for questions. Okay, what is the next part? So if you have a dipole, what is a dipole? So let's talk about dipoles now quickly. So dipoles. So if you have a negative charge and you are separating it by distance L from a positive charge, that is basically a dipole. The dipole moment, this is your dipole moment. The dipole moment is given by the charge. Let's say this is minus q, this is plus q. So you can write it as charge into length. Now in your books it is written as 2L or 2A. Let me tell you, it really doesn't matter. You write 2A or 2L. See, in your books what they have done is, they have assumed this as A, and then they write this formula as Q into 2A. Because obviously L is nothing but 2A. So it's one and the same thing, you don't have to break your head over it. Remember the direction of P is a vector, so it's always from negative to positive, minus to plus, not from plus to minus. Please keep that in mind. Great. Next, the field due to a dipole. The field due to a dipole, minus and plus. Okay. If you are at any distance r and this is theta, then what is the value of field? In general, the value of field at any point is given by, remember this basic formula, Coulomb's constant, dipole moment divided by r cube, and remember 3 cos square theta plus 1. 3 cos square theta plus 1. So if you are on the axis, then theta is 0. Axis means you are on the dipole's length. So theta will be 0. And if you are on the equator, then theta is 90 degrees. So this is a more general formula. Okay. Is that okay? Cool. Chalo. Let's get moving to the next one. Okay, perfect. I'm erasing this now. All right. Then you have torque due to a dipole. So dipole in a field. So when you have dipole in a field, what does it experience? It experiences torque. So imagine you have a positive charge, negative charge, and you place it inside some external field. Let's say this is E, and let's say this angle is theta, and this dipole moment is P. There is a torque acting on it. Okay, there is a torque acting on it. The torque is given by P cross E, which is nothing but PE sine theta. The net force on it is 0. This is only true for uniform field, not otherwise. This is only true for uniform field. Remember, when the field is non-uniform, then the net force may not be 0. The force on this charge and the force on this charge may not cancel out each other. That's something which you should keep in mind. The last thing before we start moving to the problems is Gauss's law. So we have Gauss's law. So in Gauss's law, remember, if you have multiple charges and this is Q1, Q2, Q3, Q4, let's say Q5, and you draw a closed surface, let's say like this, and this is your surface, and there is field over here, etc. Then at every point you calculate what is the flux at that point. So it will be E dot dA. That's the flux at that point on the surface. You add all the flux, that means summation, but for the entire surface, that's why closed surface integral. So this is basically for the entire closed surface. If you add the total flux, what do you get? You will get whatever charge is inside divided by epsilon naught. One more thing, This is only the charges which are inside, like Q2, then you have Q3 and then Q5. But remember one thing over here, this field that you see, this is due to inside as well as outside charges, both. This is due to inside plus outside charges. Uncharted, I'm coming for field due to different geometries as well. Yep. So please take a screenshot quickly. Yep. So Someshwar, this class will be for almost 2-3 hours, bacha. Sir, if E and S are parallel, then flux is 0. So let me tell you one simple thing. See, when the area vector and the field both are parallel, that means the flux will not be 0. The flux will not be 0. In fact, the flux will be there. Area vector itself is perpendicular to the surface. So if field is perpendicular to the surface, flux is not 0. Field, understand there is difference between surface and area vector. Surface means this surface, like the book surface. Area vector is this, perpendicular. So if field is parallel to the area vector or field is perpendicular to the surface, flux is not 0. It's only 0 when field is parallel to the surface or perpendicular to the area vector. Keep that in mind. Yeah, so be careful about that. Okay, now field due to different geometries. Due to different geometries, you should know this. First of all, if you have a charged sheet, then the field goes here also as well as here. So then this field is just given by sigma by 2 epsilon naught. It gets divided into 2. See, how do you remember whether it is by 2 or just sigma by epsilon naught? For a conducting surface, the fields are just outside. What is this? This is just a conductor. This is just a conductor. In fact, we all know that the field inside is just 0. So it only goes to the one side. So you just write it as sigma by epsilon naught. There is no half-half. Here, in the case of a sheet, which is like a thin sheet, it goes both ways. So half sigma by epsilon naught and half sigma by epsilon naught. That's how you can remember it. Is that clear? Yep. Very good. Now, sir, then when we want to add all the charges, yes, you have to just add all the charges on the RHS. Correct, make it unique. That's all. Yeah, very good. Chalo. Then the next thing that you should remember is due to a wire or a linear charge lambda. Then what is the field? The field which will be radially outward like this. So if you are at some distance r, what is the value of field? The field is, remember it like this, 1 upon 2 pi epsilon naught lambda by r. So this can be also thought of as 2 times of 1 by 4 pi epsilon naught. So whatever Coulomb's constant is there, 2 times of that lambda. What is lambda? If you have forgotten, lambda is nothing but linear charge density. Okay, linear charge density. So it will be basically Coulomb per meter. Then apart from this, which other formula you need to know? Sheet, yes, conductors, linear charge, dipole is also done. Yep, I think that's it. Spheres and shells are not there. Okay, so you can ignore that. All right, cool. Chalo, let's do some questions. Okay, are you ready for some questions? Yeah, sir, if the field is passing through the sheet, you will just add it, Kushal. In fact, there is one question like this. I'll just show you. Okay, so Arjit, for Gauss's law, I'll tell you what. Whenever, see, for example, I'll give you a simple thing. Say, you have a point charge over here. Okay, and you want to find the field due to that charge at this point without using Coulomb's law. You choose a surface, a closed surface. You choose a closed surface like this. Once you choose a closed surface, try to visualize how the field lines will look like. The field lines will look something like this, right? Correct? And at every point, the field will cut through some small area, let's say dA. So what does the statement say? It is E vector dA cos theta is equal to inside charge by epsilon naught. Now what this means is field at every point into area vector into the cosine of the angle between them. We know that the area vector is also in the same direction. So essentially theta is 0 degree. So here basically cos of 0 will become 1, so it will just become E into dA is equal to inside charge. Whatever charge is inside will come on the RHS. Here this field is field due to all the charges that are present. So Q in is just Q and this is just epsilon naught, and because E everywhere on the surface, be it here, here is constant, it will just come outside, and then you just solve the integral, which is Q by epsilon naught. So that's how you apply Gauss' law. So Gauss' law mein there are two parts, LHS and RHS. RHS mein the numerator has only the charges inside, but this LHS, the field is there for the entire charges, and this integration stands for summation, addition, adding of all the fluxes. A small flux will just be E dot dA. So the total flux will be addition of E dot dA. And what is summation? Summation is nothing but integration. And because our surface is closed, that's why you put that cyclic integral. Is that okay? Cool. Chalo, let's apply the formulas, and here are your questions coming up on your screen. Great. Ready for questions? Perfecto. Welcome Archana, welcome aboard everyone. Three charges 1, 1 and 2 microcoulomb are at the vertices A, B, C of an equilateral triangle of side 10 centimeter. What would be the resultant force at the charge C? That's the question. Come on. All right. Axial and equatorial line, that's what I just told Niveta Paras. I hope that made sense. You can use my general formula, root of 3 cos square theta plus 1. I hope that is okay. All right, Ram, let's do this. Okay, so many of you are saying C, some of you are saying D. Okay, some of you are saying B. I'll tell you a very easy way. So this is 1 microcoulomb. This is also 1 microcoulomb. Let's say this is 2 microcoulomb. This one on the 2 microcoulomb will apply a force like this along this side, correct? It will apply a force along this side. Let's say I call it F1, and this one will also apply a force this way on this side. So this is 2 microcoulomb. Now the vector addition of these two, will be the net force. That's what you need to find. So first start with F1. So what will F1 be? Force due to this charge on this charge, or this charge onto this charge. Why are they two equal? Because 1 on 2, distance is same, so forces will be same in magnitude. So F1 will be just K into Q1, Q2, use this formula, divided by R square. K is 9 into 10 to the power 9. Charges are 1 micro, so 10 to the power minus 6 into 2 micro, so 10 to the power minus 6, divided by distance. Distance is 0.1 square. So check this out. So 10 to the power minus 6, 10 to the power minus 6, 2 into 9. Okay, so this is 18. So we have minus 12, and then so it is, I'll just put it over here, 10 to the power 9 minus 12 and then plus 2. All right, so this will be 18 into, so 9 minus 12 minus 3 plus 2, so it will be basically minus 1, so it is 1.8 Newton. Now the net force, how do you find the net force? This is vector addition. See, think about it. This total angle is 60 degree because it is equilateral, and I know this angle and this angle both will be 30 degrees and 30 degrees, correct? Now think, this F1 force will have two components. This red force, the net force, will be the resultant of F1's component along that line. So F1 will have a component F1 cos 30 over here. Similarly, this force over here will also have a component here. This F1 will also have a component there. I hope you can see that. So what are those components which are adding? Those are nothing but the cos 30 components. So just use that. So F1 is, technically speaking, F is nothing but F1's cos 30 component. F1's cos 30 component, okay, plus another F1 is there, that guy's cos component also. So both together you will get the net force. So that's it. So it will be 2 times of F1 into cos of 30. So 2 times of F1. F1 is 1.8. Cos 30 is root 3 by 2. 2 goes. So root 3 is 1.7. Root 3 is almost 1.7. 32. So 1.8 into 1.7, I think it is going to come out somewhere close to 3.12. Just check this out. Just check this out. Is that okay? Yep. K is always 9 into 10 to the power 9. That is Coulomb's constant. This over here is nothing but your Coulomb constant. I just gave it to you. Coulomb constant. Correct? That was your Coulomb constant. Perfect. And how did I find R? It's already given. It's an equilateral triangle of side 10 centimeter. It is given. This is 10 centimeter. 10 centimeter is 0.1 meter. It is already given. That's why I put R as 0.1. Correct? And vector addition law use nahi karenge. Why do you want to waste that time? Yes, you can do that. If you want, you can also find F using your vector addition law. If you want, you can also use, okay, I'll just put it over here. You can also use, if you want, root of f1 square plus f1 square plus 2 f1 f2 cos 60. If you want, use that. You will still get the same answer. It's not going to be the different answer. Is that okay? Cool. Yes. So the field does not matter if the sheet is finite or infinite. It matters uncharted, but we assume that the finite sheet is also so large that we neglect the end effects. Okay, cool. Ayyappan, leave your comments after the session ends. I'll definitely help you out. Is that understood why we do cos components and why we did it that way? If you want, you can also use the vector addition formula which you have learnt in 11th standard. Got it? Perfect. Chalo, let's get moving. So these kind of questions will come for vector addition. Let me tell you, be it field, be it forces, it can come anywhere. So the two important things that you have learnt over here is the application of force. You have also learned how to calculate Coulomb's force and also vector addition. Vector addition, that's very important. So option D is correct. Yep, let's get moving to the next one. Yep, Veera, you can definitely crack it because VIT EEE's syllabus is almost similar and the questions are also similar to JEE Mains. So definitely you can. Okay, a force of 2.25 Newton acts on a charge of 15 into 10 to the power minus 4 Coulomb. The intensity of the field at that point is how much? What is the intensity of that field? So Varshad, you have missed the formula revision and you have missed the first question. So join in, you can rewind back later on, whatever you have missed. Alright, Ashika saying A, Gamer saying A. Very good Laiba, very good Prime Guru. Okay, Niveta, let's get going. Hi Dipanchi. Okay, Uncharted also saying C. Santham, Veera, Harita, all saying C. So which formula you want to use? Force is charge into the field. I just told you about it. If you have a charge placed in a field, then there is a force acting on it. So the force is 2.25, charge is 15 into 10 to the power minus 4, field is something which we don't know, so field will be 2.25, I can write it as 225 into 10 to the power minus 2, this guy I can take it below, so it will be 15 into 10 to the power minus 4, 15 will go 15 times, so it will become 15 into 10 to the power 2, so which is 1500 Newton per Coulomb. Perfecto, excellent. Let's move ahead to the next question. This was easy one. Let's get going to the next question. Perfect, perfect. You guys are doing fabulous. Very good Kakshi, very good Kani, very good Sriniti, excellent Prime, very good Srishta. Next question. We have a charge of 10 microcoulomb. It is placed at the center of a hemisphere. Radius 10 centimeter. What is the flux? Only through this hemispherical surface in SI units basically. Okay, come on, let's see how many of you can do this. Come on, my warriors, figure this out. What's the flux only flowing through the hemisphere? I'll help you a little bit. See, this charge is placed here, so the field lines will go somewhat like this. Correct? This is how the field lines will go. I feel out of the total flux that will be coming out of it, only half the flux will be going through the hemisphere. Only half the flux, correct? Why only half the flux? Because if you imagine a complete sphere, so the upper half and the lower half will have the same number of lines cutting through it. So my job has become now simple. So the flux through the hemisphere will be half of the total flux of that particular sphere. Very good. Now, how do you calculate total flux of that sphere? Remember Gauss's law? So this is direct application of Gauss law. So the total flux of any closed object or closed surface is Q by epsilon naught. So it is charge which is inside by epsilon naught. So over here I've just made use of Gauss law. Okay, I've just made use of Gauss's law. Perfect. So the next part will be half into, what is the inside charge? It is given to be 10 microcoulomb. So 10 into 10 to the power minus 6 divided by epsilon naught, which is 8.85 into 10 to the power minus 12. So you can do the math. So this will become 10 to the power minus 5, and that will become 10 to the power 10 to the power minus 5, and this will become 10 to the power 12, and you have 2 into 8.85. So check this out, how much does it come out to be? Approximately 10 to the power 7. So I can do one thing, so this is 1 upon 2 into 8.85 into 10 to the power 7. All right, so this 2 8s are 16, so closest number is 20, so 1 by 20 is 0.05, so it will be slightly more than 5. So slightly more than 5 means 6. That's what it will be. C option. Just check this out. Just check this out, because I know 1 by 20 will be 0.05. This will be somewhere like 17, 18 or something like that. So obviously when you have 1 by 20 is 0.05. So 1 by 16 or 17 will be slightly more than this. And 2 decimals gone here. So it will become 10 to the power 5. Make sense? Okay. Chalo. Let's get moving. Yes, option C is correct. Perfecto. Moving on to the next question. Yes. So Sai Rama Srinivas, this session will be for 2-3 hours at least. Okay. Let's get going. So the radius does not matter here at all. Yes, Krishna, because no matter how big the radius is, the lines will eventually cut either now or then or later. So as soon as it cuts, the flux is counted. So it doesn't matter whether you count it here or there. Makes sense. Yes, Biot-Savart's law will also be covered. A lot of students are saying A. Well, let's see whether you guys are correct or whether you guys are wrong. If this charge is placed here, what you need to do, visualize a bigger cube. And how? Like this. Okay, look at this. I'm just going to draw a bigger cube over here. Just going to draw some more cubes right in front of you. Okay, I hope now you are able to visualize. Yep, like this over here. Okay, perfect. So can you see what I have done? I have added 3 cubes over here. One was the original one, 2, 3, 4. More such 4 cubes below. Okay, more such 4 cubes below. So it will look something like this. I hope you can visualize. Now for that big cube surface, which surface am I talking about? This entire surface, this entire big surface, the total flux by Gauss's law is Q by epsilon naught, correct? But that entire surface is made of 8 cubes. The entire surface is made of 8 cubes. Do you understand? So through any one cube, like the one over here, through any one cube, it will be 1/8 of the total. So 1/8 of the total means 1 by 8 of Q by epsilon naught. Think of the cube at the center of that big cube. 1/8 is going here, 1/8 is going there, 1/8 is going here. So 8 cubes it is getting distributed. So hence the answer is A. Perfect. Very good. Very good. How do you use F cos theta in the first question? Swani is asking. Okay. So vector resolution. Were you there in 11th standard? That's it. So you have the force over here and this is theta. So what is this? This is F cos theta and this is F sin theta, right? So in this question over here, if this was F1 and let's say I want to bisect, this is 30 degrees. So how much will this be? How much will this be? This will be F1 cos 30 and obviously F1 sin 30 will be over here. That's standard, right? That's how it will be. This will be perpendicular. Makes sense? Got it? Chalo, let's get moving to the next one. Yes, option A is correct. Next. What is the flux from each face? Now that will be a tricky one. So if you want to calculate it from each face, then you divide it by 3, because each of those cubes will have 3 faces through which the flux will be flowing, correct? So it will be then Q by 24 epsilon naught. Okay, now many of you are saying B, some of you are saying A. Clearly students are confused. Alright, so let's visualize the diagram. First of all, 2 infinite plane parallel sheets separated by some distance, okay, have equal and opposite uniform charge densities. So if this is positive, okay, then this is negative. Okay, so because of positive, the field lines will look like this. Because of positive, the field lines will look like this. And because of negative, it will be attractive. So it will end over here. It will end over here like this. This is how the field lines will look like. The field at a point between the sheets. That means you are somewhere over here at this point. I think I know what to do. The fields will add. So the field over there will be the field due to the positive charge, also plus the field due to the negative charge. Why? Look at the arrow marks. Positive field is also that right side, negative field is also right side. So they are going to add, they are not going to subtract. That's the common mistake, and many students mark 0 and they get a 0 mark over there as well. So field due to any one sheet, what is it? Sigma by 2 epsilon naught. This is also sigma by 2 epsilon naught. This is plus. So 2 by 2 sigma by epsilon naught. So this is nothing but sigma by epsilon naught. That is option B. Option B. Very good. Very good. Got it? Excellent. So that's how. Oh, by the way, this is also a capacitor. At the end of the day, this is nothing but a capacitor. Cool. Let's get moving to the next one. Sigma by epsilon naught is correct. Moving ahead to the next one. How do you know there are 8 cubes? Shrishta? Okay, meanwhile you guys solve this. Think simply, there was 1 cube over here. Obviously, you can add 1 more cube here. You can add 1 more cube here. And you can add 1 more cube here. So how many cubes are there here? Totally 4 cubes are there. Same thing, you can do it below. So 4 cubes are there. So 4 on the top, 4 below. How many cubes? 8 cubes, right? Makes sense? So 4 on the top, 4 below, and your charge is at the center. That's the reason for that. Alright, I hope that makes sense. Okay, many of you are already marking D. Okay, electric dipole with moment of this much is aligned at 30 degrees with the direction of the field. Okay, the magnitude of the torque on the dipole. So what do we do? So the torque will be P E sine theta. Okay, that's the formula for torque. So we are using the torque formula here for dipole. So dipole moment is already given. So 2 into 10 to the power minus 9. Electric field is already given. 4 into 10 to the power 4. Sine theta. So sine of 30 degrees. So let's do this. 2 4s are 8. And we have 10 to the power minus 9 into 10 to the power 4. Sine 30 is half. So 2 goes. This will become 4. Yes, so 4 into 10 to the power minus 5. Just check this out. Option D, everybody is getting it. Very good, very good, very good. Proud of you, my warriors. Let's get moving to the next one. Excellent. I can see that many of you are going to score full marks. Very good. See, CBSE paper is simple. It's at max average. Okay, it's nowhere compared to JEE mains level or even JEE advanced level or even NEET level. So basically, if you are preparing for JEE and preparing for NEET, your term 1 examinations will be this easy, and term 2 will be even more easy because you would have finished the portion much before your term 2 examination. So by the way, even we are having lots of courses even during this time. Even if you are confident that let's say for example you are confident that okay, my term 1 examination is simple, it's going to be easy, and if you think that you want to prepare for term 2 along with JEE, let me tell you, my courses, crash courses are still available, so you can go ahead and check out the links which are there in the description box. So we have these 3 charges and they are placed at the corners of an equilateral triangle. What is the magnitude of the electrical dipole moment? Okay, so Ashutosh, you'll have to wait for some JEE advanced session for very difficult questions, but yes, there are some good questions as well over here. But that is again of CBSE level. I am helpless. Okay, so don't ask me very difficult questions. Okay, we are going to have very difficult questions coming very soon. So this is how the charges are. Oops, sorry, I think I added exactly ulta. This is plus plus and this is minus. Okay. Now, once you know these are the charges, here is what I'm going to do. This negative 2q, I will just write it as minus q and minus q. Reason is, I know that this plus q and this minus q forms a dipole. This minus q and this plus q also forms another dipole. Each dipole will have its own dipole moment. Let's say I call it P1. This will be also P1. Agreed? This will be P1. This will be also P1. So what is the P1's value? It will be the charge, which is Q, into the length. What is the side length? The side length is given to be L. So it will be Q into L. Don't put it as 2L. It creates confusion. That's why I tell you, don't remember the formula of dipole as charge into 2L. You'll be like, sir, what was L? Was it half? You get confused. So L is just the separation. That's it. Great. Now, the total dipole, the net dipole, will be the vector addition of P1 and this P1. This P1 and this P1. So, when you add them vectorially, if you want, you can directly use this formula, which you have studied back in vectors. So it is P1 square plus P1 square plus 2 P1 cos 60. Let's do this. So P1 is common, so P1 just comes outside. 1 plus 2 into cos 60 is half. 2 goes, this becomes 1, so it will become P1 root 3. So P1 is nothing but Q into L into root 3. So Q into L into root 3, which is option C. Very good. Very good. Yes. If it is minus 3q, then it will not form a dipole. You have to always try to form pairs, equal, positive and negative. Okay. So that's what you are always going to do. So if it is positive, negative over here, you can make a pair here and here. If it is double plus, negative, okay, negative, and let's say another positive over here, you can make one pair here, you can make one pair here and one pair here. So it always has to be equal in number. Keep this in mind. Okay, option C is correct. Moving on to the next one. Okay, why not 2L? Eben, oh my god, see bacha. What is the formula for a dipole moment? It is Q into separation. It is not 2L. That's what is the mistake of, these books. They confuse students. Separation. What is the separation between this charge and this charge? It is L, right? So that's why the separation is L. So when they put the formula in your books, minus and plus, they put this as 2L. Why do you want to confuse? Just remember, it is charge into separation between the charges. Is that clear, bacha? Is that clear? Okay. Why can't you take P1 and P2? Yes, you can take P1 and P2. But why did I take P1 and P1? The reason was, I just knew if this is P1 and if this is P2, magnitude wise, they both are same. Because this is equal amounts of positive and negative. Distance is also same. So magnitude wise, both were same. That's why I took it. Else I would have taken it as P1 and P2. What's the harm in that? There's no harm in that. Yes, so Sachin, if you have studied at 2QA, that is something which you should forget. Okay, so that is what many institutes and many teachers fail to explain, and that creates even more confusion. So my method is always remember dipole moment as charge into length, not as 2L. 2L creates confusion. L is the best way to remember, because you have the clear clarity that yes, L is just the distance between the positive and the negative charges. The moment you put that 2 there, everything just goes haywire. So don't remember it. Don't remember 2L. That's random. That's wrong. Don't remember it. Okay? It's going to create lots of confusion. Okay? And 60 degree is just, yes, because it's equilateral triangle. Obviously, Kirtana, equilateral triangle 60 degrees. Okay? Mohammed, if you want to learn vectors again, I would advise you to join crash course. So crash course will start right from beginning, right from vectors till the last part. Okay, great. Okay, how do we use F1 cos theta? My god, Swahani, I think I just gave you the answer before that. Okay, 2L use nahi karna hai. 2L use nahi karna hai, bachcha, Ibn. 2L is wrong. 2L is don't remember that. just forget it. 2L करके कुछ चीज था, भूल जाओ उसको. Just remember charge into L. Okay, that's it. Yes. Cool. The value of P1 is not 1. I had taken P1 outside. P1 square was outside. Yes. Okay, P1 square was outside. चलो मैं थोड़ा अभी स्लो पढ़ाऊंगा. मेरे को लग रहा है कि you guys are not grasping it so quickly. तो I'm just going to go little bit slow because मेरे को ऐसा लग रहा है कि आप लोग को थोड़ा समझने में थोड़ा स्पीड में दिक्कत हो रहा है. Okay, don't worry, I'll go slow. An infinite line charge produces this much field at this much distance. Find out the field find out the linear charge density. अच्छा देखो क्या है. We have a line charge. We have a line charge like this. Okay, it creates a field around it. It creates a field around it. Okay. Now the question is, find out what is the linear charge density if the field is given. First of all, what is the formula that we know? Field is 1 upon 2 pi epsilon naught lambda by r. That is the standard formula for linear charge density. Okay. Now, what is the value of field given? 9 into 10 to the power 4. This number over here, I can write it down like this. 2 times of 1 by 4 pi epsilon naught, because this value I know. Lambda, I don't know. R, distance is already given 2 centimeter. Centimeters means 2 into 10 to the power minus 2. Now, already many things are getting cancelled, like 2 and 2. Then, let's see what else happens over here. Okay, so we have 9 and then this goes over here. So it will become 10 to the power 2 is equal to 1 by 4 pi epsilon naught is 9 into 10 to the power 9 into lambda. So you can again see 9 and 9 gets cancelled. So we just have 10 to the power 2 into 10 to the power minus 9 is equal to lambda. So lambda is 10 to the power minus 7. So 10 to the power minus 7. Just check this out. Are you getting it as 10 to the power minus 7? Yep. So it will be how much? D. Yes. There is no shortcut method for linear charge density. Just remember this. So if you want, you can always remember this formula as 2 times of Coulomb's constant into lambda by r. If you want, you can remember it like this. It's one and the same thing. Okay, make it unique. Yep. Very good. Very good. Chalo, let's get moving to the next one coming up. Okay. Very good. Very good. Chalo, let's get moving. Here we have done. Oh, by the way, let me also tell you there is a marathon sessions going on right on our Vedantu platform. So if you are a vPro student, then you can access it for free. But if you want to access it, even if you are outside and you want to access all the chapter wise tests as well as the discussions that are happening on our platform, you can avail the course which is there in the description box for 899 rupees for physics, chemistry and biology. Okay, so marathon sessions going on right now in our Vedantu platform. Let's move on to electrostatic potential and capacitance quickly, and let's have the formulas out here. Some important formulas which I would like to give you is the relationship between work, potential energy. Okay, so very, very important. Work done by any force or in general we know is integral force dot displacement. But when you talk about work done by conservative force, it is always negative delta U, where this delta U refers to the change in potential energy, meaning final potential energy minus initial potential energy. There is a difference. So for example, you have, let's see whether you can get this. You have a positive charge and you have a negative charge. Okay, now you bring these two charges closer. What do you guys suggest? Has the potential energy over here, and this is the final position. If this was initial potential energy, this is final potential energy, do you think the potential energy has decreased or has it increased? Come on, let me see if you can get this. Has the potential energy increased or has it decreased? P is dipole. P is dipole. It has decreased. Yep, it has in fact decreased. Potential energy has decreased. Now if I ask you what is the force? Well, the force is attractive, and is the force doing this force by electrostatic? Electrostatic force is a conservative force. Is the force doing positive work or negative work? The work done by that electric force, is it Positive or is it negative? That answer will be positive because the force and the displacements are in the same direction. Okay, because force and the displacements are in the same direction, correct? Now, if you look at this formula, work done by that force is negative delta U. If you notice, the energy has decreased. So if I ask you what is delta U will be negative because energy has decreased. So hence, work and change in energy will always be of opposite signs. That's what you need to keep in mind. Work done by that internal conservative force will be always negative of the change in potential energy. Remember this. Alright, moving ahead to the next one. Yep. So the next one that you have is, I'm going to give you a beautiful chart for remembering force, potential energy and all these things. So look at this. If you have force, you can go to field, you can also go to energy, you can also go to potential. How do you define force? Force, everybody knows it is K Q1 Q2 or K QQ by R square. Field is nothing but K Q by R square. Potential energy is K Q Q by R. Potential is just K Q by R. You can see one alphabet continues to be stripped away. It goes off for each and every formula. Now, when you want to go from force to field, you basically use this limit. Limit force by charge, Q tends to 0. Same way, when you want to go from energy to potential, limit potential energy per unit charge, Q tends to 0, gives you potential. Energy per unit charge is called potential. Same way, if you go back, okay, like this, then from field if you want to find force, so force will be charge into field. We know this formula. Same way, from potential you want to go to energy, so the potential energy will be charge into the potential. But this is a scalar equation, there will be no vector. Very good. Hello Logesh, welcome. Yep. So the chat is continuous even. Okay. Next, from force, if you want to go to potential energy, there is an interesting way. So force and potential energy, how are they related with each other? F is minus du by dr. Keep this in mind. Force is minus du by dr. Same way, field and potential are also related with each other. Electric field is minus dv by dr. What is this dv by dr called? dv by dr is also called as potential gradient. Potential gradient. It also means one thing. If you have electric field lines, the electric field lines always go from high voltage or high potential to low voltage. They are always perpendicular to the equipotential lines. That's what this statement means. Perfect. So this chart helps you remember all the formulas in one go. You can see this. You can go from any place to any place in a very easy manner. Force to field, potential to potential energy, force to potential energy, potential to field. It's all the same thing. Remember, this side is all everything like force or energy per unit charge. So you get field and potential per unit charge. That's all it is. Okay, cool. So these are the formulas that you need to keep in mind. Now, what is the difference between energy and potential? See, whenever you have 3 or 4 charges, let's say 1, 2, 3, 4, each pair of charge will have energy between them. Like the potential energy between 1 and 2 will be K Q1 Q2 divided by R. Similarly between 2 and 4. Similarly between 1 and 3. Similarly between 3 and 4. Similarly between 1 and 4. Similarly between 2 and 3. You will have all these terms. So if somebody asks you energy of that particular system, then it will be all those terms added together. It's the total energy of that system. But when somebody asks you potential, it's not of the system, but in fact it is the potential at a point. So if somebody asks you what is the potential at, let's say, some point over here P, then it is potential due to charge 1, potential due to charge 2, potential due to charge 3, potential due to charge 4. So it will be just V1 plus V2 plus V3 plus V4. That's it. So potential due to each charge, you just have to add it as a scalar. That's it. Because potential, remember, is a scalar quantity. Potential just refers to ability, or ability for a charge to create potential energy, or basically it is the work done per unit test charge to bring it from infinity to that particular point. Okay, that's what it is. Perfect. So understand the difference between energy is of a system, potential is at a point, it's not yet there, energy is not yet there, it just has the ability. When you place the charge, then it is going to get the energy. Fair enough. Next, let's go ahead to the next one. So potential formula for a dipole. So standard. So if you again have a dipole, again I am repeating this. If you have negative charge, positive charge, dipole, this is length L. The dipole moment is Q into L, not a 2L. Understand? It's the same thing, guys. If you have a negative charge, positive charge, and if I call this as 2A, then I can also call dipole moment as Q into 2A. Here basically 2A is equal to L. It's one and the same thing. There is no difference, but this is not preferred, this is preferred. This is there in your books, but you're not going to remember this. In fact, you're going to remember this. That is going to make your job easy. But if you want to fall in the pit, then I'm nobody to stop it. So please go and fall if you are not convinced with this method. Alright, next, the thing is, if you find the potential at any point, if you want to find the potential at any point at a distance r, then that is just given by K, which is your Coulomb's constant, standard 9 into 10 to the power 9, into P, Kp, and then you have cos theta divided by r square. One thing that you should keep in mind. Okay, so Logesh, this class is for at least 2-3 hours. This is at least for 2-3 hours. This is r square. Usually, due to a point charge, when you have potential, you have kq by r. This r is there. Why is there r square here? Reason is this P has the dimensions of length. Because this has the dimensions of length, so you have to increase the dimension in the denominator. So that's how you can keep in mind it is r square. Remember, for field, it was r cube. This is a common mistake which students make. Okay, I hope this is clear. Okay, so when you move from a charge from high potential to low potential, will the energy increase or decrease? Simple. So very interesting question somebody has asked. So if this is low potential, this is high potential, and let's say you take a charge from here to here. It depends whether it is positive or negative. So for negative it will be different, and for positive it will be different. So if you take a positive charge, it will be different, and for negative it will be different. Let's see what it will be. So from low to high. So when you take a positive charge from low to high and potential, obviously the energy will increase. But if you take a negative charge, then that energy will decrease. Is that okay? Perfect, perfect, perfect. Great. Chalo. Let's get going ahead. I hope you can understand this point still here. Capacitor formulas. Let's have a look at the formulas in capacitor. So first formula, Q is equal to CV. What is C? C is basically your capacitance. What does this stand for? If you have two conductors, one is positive, one is negative, then there is field between them. There is energy stored between these two conductors which are having a potential difference of V. So one conductor stores plus Q charge, other conductor stores minus Q charge. This charge is related to the voltage with this formula. The amount which it can store on each one is being defined by that capacitance. So capacitance tells you how much charge it can store per unit voltage. Next, how much energy it stores is nothing but half CV square, which is also half Q square by C, or which is also half Q into V. One and the same thing, there is no difference. Perfect, perfect. So Sushma, what do you mean by if you take a dipole? Okay. So what's the difference between Kp cos theta, r square and field? So I think I mentioned it before already. So when you have field, there is a term of root 3 cos square theta plus 1. When it is potential, it is just cos theta. and in case of field there is r cube, and in case of potential there is r square. Everything else is same. So this is Kp, this is also Kp. Everything else is same. Okay, I hope that makes sense. This is what it is for a dipole. All right, moving ahead. Now the next thing, capacitance for parallel plate. Capacitance for parallel plate capacitor is epsilon naught A by D. Epsilon naught A by D. But if you add any medium, then the capacitance becomes K times as compared to when there is nothing inside it. This K is not your 9 to 10 to the power 9. This is called as your dielectric constant. This is called as your dielectric constant. Keep this in mind. Very good. Excellent. Next thing, energy per unit volume. What is energy per unit volume called? It is called as energy density. It is called as energy density. So any field stores energy. How much energy it stores per unit volume is called as energy density. It is given by half epsilon naught E square. So whenever you have field, okay, if you take 1 unit volume out of it, how much energy is there in that field between the capacitor plates or anything in general? Half epsilon naught E square. Perfect. Now the next thing I want you to focus on is also capacitors combination. So say for example, okay, they are in series, very important. So like this, understand each of them will have the same charge, and this is C1, C2, C3, then 1 by C effective is just 1 by C1 plus 1 by C2 plus 1 by C3. So it's exactly reverse to that of resistors. And also remember one thing, the charges are same but the voltages are different. V1, V2, V3. For example, if you want to find V3, use this. It will be Q by C3 because Q is CV. So V will be Q by C for any particular voltage. So it will be Q by C1. Similarly, when it is in parallel, when you have capacitors in parallel, so like this, okay, you have capacitors like this in parallel. This is C1, this is C2, this is C3. In this case, what will be different is the charge. This will be Q1, this will be Q2, this will be Q3. What will be same? Voltage will be same. So you will see voltage is basically same throughout, and C effective will be C1 plus C2 plus C3. Okay, so that's the difference. And if somebody wants to find Q3, Q3 is C3 into V. Q1 is C1 into V. Just use Q is equal to CV formula. That's it. Okay, is that clear? Very good. So Sushma, if you take dipole from high to low potential, well, let me tell you, nothing will happen because see, when you are not changing the orientation and you are taking it in a uniform field, then the work done on the positive charge and the negative charge will be same. So the net work done will be 0 if you are not changing the orientation. The energy changes in a dipole only when you change the orientation. So keep that in mind. Okay, only when you change the orientation. Perfect. Now force between the plates and all of that is not there. It's there for JEE means. For CBSE point of view, it is not there. So if you are obviously preparing for JEE, then you will find a lot of things missing in CBSE. You will not find so many complicated formulas because so many things are deleted or not there for board's perspective. Okay, so don't worry about it. Great. So let's do some questions based on this. Ready? Sir, even if you decrease or increase the potential, capacitance is constant? Yes, because it only depends on the material and the shape and the size, nothing else. Alright, come on, let's see if we can do this question. Okay, yep, there we have our first question. Come on, let's see. The potential at a point due to the charge is how much? Come on, this is easy one. Come on. Let's do this. Potential at any point, okay, we know is given by K, Q by R. And this K is 9 into 10 to the power 9. Charge is 5 into 10 to the power minus 7. and distance is 10 centimeter, meaning 0.1 meter. So 9 5s are 45, I think. Yep, yeah, correct. So there we go, into 10 to the power 9, 0.1 goes up 10 to the power 10 and 1 and 10 to the power minus 7. So this will be 45 into 10 to the power 3. So just check this out, 45 into 10 to the power 3 is 4.5 into 10 to the power 4. So option C, perfect. Option C is correct. You can see that. Option C is correct. So 4.5 into 10 to the power 4. That's what it will happen. Perfect. Let's get going to the next one. Moving ahead, 4 equal charges are placed at 4 corners of a square of side A each. Work done in carrying a charge from minus q from its center to infinity. Now this is going to take some time. Let's see how many of you can do it. In capacitance with series, obviously it is opposite of that of resistors. So for series, use parallel formula for resistors, and for parallel capacitance, use series formulas, whatever you use for resistance. It's exactly opposite. Okay, moving ahead. Now the answer is definitely not what you guys are thinking it to be. Okay, well. All of you are saying A, sure, Paka. Wow, very good, excellent. Some of you are getting a wrong answer. The correct answer is different. Look at this, you guys are getting it wrong. Option B, be careful. Why is it option B? I'll show you. See, you guys got it wrong. Where are the 4 charges? The 4 charges are here on the vertices of the square. So these are the 4 charges. Now you take a charge minus q. Minus q is over here. And you take it from here till infinity. Okay, we know one thing, at infinity energy is 0. So the question is, what is the work done? The work done by external force, remember, is exactly opposite of the work done by the internal conservative forces. So whatever work you do will be utilized, okay, by the internal forces. So if you don't understand this, it's okay. Remember, whatever work you do goes in changing the energy of the system. It goes directly in changing the energy of the system, which will be final energy minus initial energy. The final energy means energy at infinity. Basically this is infinity. So at infinity the energy is 0. Initial energy is something which you need to calculate. Okay, now look at this. Here you need to find out how much energy did this charge have with respect to this and this. For that you need to know how much is this distance. Now we all know in a square, the diagonal, if this is A, this diagonal is root 2 times of A. So this part will be half of root 2A, which is just A by root 2. Correct? This is just half of that diagonal. I will need that because I need how much distance is the charge away from any of the corners. So initial energy, how do you calculate? There will be 4 terms. Energy with this, energy with this, energy with this, energy with this. So 4 terms will be there. So 4 into energy from each corner. Energy from each basically corner. So what will it be? Let's try to calculate this. K, Q1, Q2 by R. K is K, Q1 is Q, Q2 is minus Q divided by R. R is nothing but A by root 2. So minus and minus cancels. So it will become 4K Q square, and this root 2 is also there. Okay, root 2 divided by A. Now K value you can put. So 4 root 2, 1 by 4 pi epsilon naught, and you have Q square by A. This 4 and this 4 cancels. So root 2 Q square by pi epsilon naught A. So hence option B is correct. Got it? Very good. So magnetism chapter, yes, cyclotron is deleted. Thank you, Litish. Perfect. Understood, guys? So that's all it is. It's a very common silly mistake. Many students think it is 0. I don't know why you guys think of it as 0. It is not 0. This charge with this with this had energy. When you shoot it away, the energy disappeared. At infinity it became 0. So the work done was change in the energy. So just use the formula of electrostatic energy. We have applied it directly. Okay, perfect. So next question. The work required to put the 4 charges together at the corners of a square of side A is how much? Let's see how many of you can do this question. The work required to put all the charges at the corner of a square. So you have to assemble it. This is also a kind of question which comes. Ln, Triln, OTR, final energy is 0 because of yesterday's session I mentioned it. You assume the energy when infinite separation is there is 0. That is your reference energy. So even if you put the formula kq by r, when r is very large, energy will become 0. So that's how it is 0. Okay. Chalo, let's see how many of you can do this. Many of you are confused between A and C. Okay. A and C. Okay. Sure. A is the guess. Well, the answer is B. I'll tell you how to do this problem. Okay. See, what you need to do is find energy between 1, 2, 2, 3, 3, 4, 4, 1, 1, 3 and 2, 1. All the combinations. So the total work done is basically nothing but the energy of that particular system. Okay. Now let's just calculate this. What is that energy of that system? Okay, let's just calculate that potential energy of that particular system. It will be U12 plus U23 plus U34 plus U41 plus U13 plus U24. So many terms are there. U12 will be, think about it, it will be K, Q1 and Q2. Both are opposite. So Q into Q, which will be minus Q divided by distance, which is A. Okay, side length is A. Similarly, U23 will be negative positive. So again, it will become, K, Q minus Q divided by A. So like that, there will be totally 4 terms together. 4 terms. 1, 2, 3 and 4. Till this 4, 1. Each time the charges are opposite, you can see that. The last 2 terms, QQ minus minus. Minus into minus is also plus. Keep that in mind. So for 1 into 3, what will be your potential energy? Think. So it will be K, Q into Q divided by this distance, which is root 2A. That's the length of the diagonal of a square. Everybody knows this. So root 2A and plus K into minus Q. It is anyways going to be positive divided by A. Now you can see everywhere K, Q square by A is constant. It's common. So K, Q square by A is common. Here you get minus 1, here you get minus 1, here you get minus 1, here you get minus 1. 4 times. Here you get plus 1 by root 2 and here you get plus 1 by root 2. Basically this will become K, Q square by A. Here you will get, minus 4 plus 2 by root 2, which is just root 2. Just calculate this, you will get the answer. Just calculate this. Just calculate this. Oh, sorry. Here I had to put root 2A. Yep. So that's it. Just calculate this. You'll get the answer. As simple as that. Got it? Perfect. Understood? So it's actually not lengthy. If you're used to solving these questions, this is a standard question which is done. Even in my regular Pathfinder series, when I have completed this chapter, I have done these kind of questions. So you already know this. It's just a matter of calculation. And you should immediately think, acha, K, Q, Q will be common everywhere. You should not even do this step. You should not even do this step. Your first step should be this. How many of you can start from here? Raise your hand. How many of you can start it right from here? Think. Okay. So let's see. Yeah, very good. Very good. Very good. Some of you are able to solve this. Very good. So if you are able to, so if you are able to solve right from here, that's very good. So you will save a lot of time writing all these steps. Perfect. Now, okay, this is done. Let's get moving ahead to the next question. The charge on the 3 microfarad capacitor is, come on, let's see how many of you can do this. The charge on the 3 microfarad capacitor shown in the figure is how much? Let's see if you can do this really quick. First, what you need to find, these are 3 capacitors on the series. That means all of them have the same charge. All of them will have same charge. That's understood. Okay. Can we write this as one single capacitor with that same charge? Okay, what will this C be equal to? I think I can find it out like this. 1 by C is equal to 1 by 2 plus 1 by 6 plus 1 by 6, sorry, 1 by 3 plus 1 by 6. LCM will be 6. So this will be 3, this will be 2, this will be 1, whole thing divided by 6. 3 plus 2 plus 1 is 6, 6 by 6, which is 1 by 1. So capacitance is 1 microfarad. Okay, so capacitance is 1 microfarad, we got it. So what is the charge on this? The charge will be C into V. C is 1 micro, okay, into voltage. Voltage is 10, so it will be 10 microcoulombs. So answer is 10 microcoulombs. That's it, done, done. Okay, yes, the only extra preparation JEE students need is just practice of those kind of questions within the time. Your speed matters and that knowledge of NCERT matters. So that's the only extra preparation you need to do. Perfect, because JEE problems are slightly more on the conceptual side and more on the analytical skill sides and all of that. Okay, so we have a parallel plate capacitor of capacitance C. Half of it is filled with constant K, dielectric material. How much is the percentage change in the capacitance? Beautiful question. Okay, so yes, you're going to get break after some time. Yep, hold on. So after one more chapter maybe. Current electricity. So what do we need to do over here? Think. This capacitor can be divided into two parts. The upper part and the lower part. Upper part is having air, lower part is having the dielectric material. So I can write it like this. Just write it like this. Okay, just think about it. Yep. Two capacitors in parallel, one of them has dielectric, the other one does not have dielectric. Correct? Okay. Now we know what happens when capacitors are in parallel. They just add. Okay, the equivalent capacitance just will be the addition of them. What will be the capacitance of this part? And what will be the capacitance of this part before I add it? So for that, think this way. If the original area was A, if the original area of the plates was A, this plate will have area A by 2, this plate will have area A by 2. So this capacitance will be epsilon naught A by 2 by D. This capacitor will have a capacitance of epsilon naught but dielectric constant, which is 5. So into 5 into A by 2 by D. Perfect? Okay. So the total effective capacitance will be just C1 plus C2 because they are in parallel. Keep this in mind. You just add them. So that plus that. So epsilon naught A by 2D is there. This is the first term, but the second term just has 5. So this will become just 6 in the next step. So epsilon naught A by 2D, 1 plus 5, 1 plus 5 is just 6. So this 2 and this 6 goes, this will become 3. So 3 epsilon naught A by D. 3 epsilon naught A by D. So epsilon naught A by D is the capacitance initial. So what is this C effective? This C effective is giving me the new capacitance. So earlier it was C, now it has become 3C. How much is the change? How much is the change? Is it 200%? Is it 400%? What do you guys say? Is it B? Think again. Be careful. I don't know why you guys are saying B. Is it B option? Think again. How is it B? Earlier it was 100. Now it has become 300. So how much is the percentage change? How much is the percentage change? Be careful. 33%? What are you guys saying? How is it 33%? How is it 33%? It is D. What are you guys saying? It was 100 for example. Now it becomes 3 times of that. It becomes 300. What's the percentage increase? How much is the increase? The increase will be 2C. 2C means twice. 200% increase. Guys, be careful about this. Many of you made a mistake over here. You had 100 laddus. Now you have 300 laddus. How much is the increase? The increase is 200 laddus. So how much is the percentage increase? Think about it. Okay, so it's 200%. Yep, be careful. Many of you made that mistake. 16 picofarad capacitor is connected to 80 volt supply. The amount of energy stored in it is how much? Come on, let's do this. Simple direct application based questions. These kind of questions are going to come in the examination. Direct application. Yeah, why not possible? क्यों नहीं possible है? 200%. So when you add dielectric, Rahul, what happens? Capacitance increases that many times. If the constant is 2, it becomes 2 times. So if capacitance becomes 2 times, obviously everything else in it also starts changing accordingly. Understand that. Okay, so amount of energy stored is nothing but half. Which formula will I use? Capacitance is given, voltage is given. So half CV square. So capacitance is 16 pico. Pico is 10 to the power minus 12 into voltage, which is 80 square. So this will become just 8. So 8 into 10 to the power minus 12 into, I'll write this as 8 square into 10 raised to 2. 8 cube. 8 cube is 512. This will become into 10 to the power minus 10. So I think this will be the answer. Just check this out. This will be the answer. 5.12 into 10 to the power minus 8. Okay, you can just shift the decimals. 5.12 into 10 to the power minus 8. You can just take the 2 decimals inside. Yep, perfect, perfect, very good, excellent. Moving ahead to the next one. Okay, current electricity. All right, it can decrease, Ashutosh, only if the dielectric is removed. Okay, not before that. Okay, there are very few formulas here, and then let's straight away go to some questions. Okay, let's get going. Ready? Uncharted, the work done minus of U, so shouldn't it be C? I think you're referring to some previous question. If it was work done which was asked, work done is final minus initial. You are saying for the previous one. Which one? This one somewhere here. Oh, this one. The work required to put the 4 charges together. I think we got the answer as negative. Yes. If it is the work done which is asked, yep. If it was a work done which is asked, the work done will be final minus initial potential energy. Now let's see, the final answer in this situation was negative. Initial was 0 because initial means it was at infinity. So the final answer will be negative. So it is correct only, bacha. It is correct. It is fine. Uncharted, it is fine. Perfectly fine. Final itself is negative. We got the answer of energy itself as negative. So it comes out to be negative. Is that okay? Sarvana, if you keep solving problems now, it becomes easy. And another easy way to remember energy stored in a capacitor is, remember energy stored in a spring is half kx square. So if you remember this, you can get this also. I'll tell you why. X is similar to charge and spring constant is similar to 1 by c. So if you remember that, you will get this. K is similar to 1 by c and x is similar to charge. So half q square by c. Half q square by c. One and the same thing. There are direct relationships. Yeah. No, final is not infinity. You are bringing the charges together. Read the question. Required to put the 4 charges together. So what is final? Final is what is given. Initial will be, they are very far away. So that's why understand initial is 0. Understood? Got it? Final is not infinity. Read the question. Work done to put them together. That means what? The charges were very, very far away. Now you brought them from infinity very close to each other. So final is not 0. Be careful. Yeah, common mistake. Common mistake. Very good. Very good. Yeah. All right. Understood. Perfect. Great. Let's move on. Okay. So this work is done by the external force. Okay. So this common misconception is there between many students. Sir, I never understand. Work is delta U or work is minus delta U. Let me tell you the difference. Work done by external force is plus delta U. Work done by that internal conservative forces is, okay, so that basically that conservative forces is a negative delta U. So this is the actual relationship. And here what has been asked is the work done externally, not internal. Be careful about it. Cool? Chalo. Perfect. Understood? Let's get going. All right. Are you now ready? Convinced? Perfect. Everything done? Doubts cleared? Uncharted? Very good. Hi Anjani. Okay. Okay. My battery is running low. Which battery is running low? There's nothing is on battery. This is all powered by electricity remains. Okay. Alright, so let's get going. Yes, PBSN, I will be taking water after some time, after I finish this much part of current electricity. Okay, chalo, current electricity के formulas फटाफट कर लेते हैं. Okay, so what do we have in current electricity? We have current is charge by time, and charge will be integral of current with respect to time that flows through any conductor. So how much charge that flows through, it. And we also know the current density formula. This is the density formula, which is I by A, and this is a vector quantity in direction of current. So the current per unit area, that is how J is. Now, the next formulas that you should remember is Ohm's law and their respective things, like V is equal to IR. This R, you can write it as resistivity into L by A. This rho depends on the material. It depends completely on the material. Also, this rho also depends on the temperature, like this. Rho naught into 1 plus alpha delta T. This alpha is called coefficient of thermal resistance. Thermal resistance. If you change the temperature, resistivity changes, the resistance changes. Length changes, area changes, then also resistance changes. Okay, now this current has already been defined over here. Now you have some more terms which you can remember, like, the electric field which is there. So the electrons move, right? So there will be definitely motion of electrons. There is motion of electrons like this. They move with some speed called as the drift speed. And the reason why the electrons move is because you applied potential difference, and potential difference always creates electric field. So if you want to modify this formula, you can do that, and it looks like this. E is equal to, so voltage per unit length is electric field. Instead of current, you put current per unit area, which is current density, and instead of resistance, you use specific resistance of that material, which is resistivity. This formula is also valid, but this is a vector equation. Remember that. It's equivalent of Ohm's law. Field is always, in the direction of the, field is always in the direction of, the current density. Great. Moving ahead to the next one. All right. Now, what do we have next? The drift speed. This drift speed, the speed with which, the electrons move. There are different ways in which you can write it. First is current is equal to NVDR. So when I say N, it is the charge. It is basically the charge per unit volume. It is the charge per unit volume. VD is the drift speed, E is the electron charge, A is area, I is current. This is one formula, right? There is another formula. And the way to remember this, I have already been telling you this. NVIDIA, it's a graphics card company. I have told you this. NVIDIA, that's how you can remember it. Similarly, you can also remember one more formula. Remember like this and remember like this. This J and ulta J. And just put over here N E square by M and E. Okay, just put this. What happens because of that? Now I'll tell you what. This J is current density. This N is the same, charge per unit volume. E is electron charge. M is the mass of the charge. This is a mass. This tau is basically called as your relaxation time. Relaxation time. That means when an electron accelerates before it collides and then again accelerates, how much time it takes from one collision to the next collision. That's relaxation time, and this E is nothing but your electric field. So this is also very important, very easy to remember. First put J, then put tau there, NE square by M, NE square by M, and then put one more E. That's all. So that is another formula which you can remember. Perfect. Then mobility and all of that, yes, we have to put that. So let's put mobility as well. So mobility formulas, some questions can come. Mu is speed per unit field. So drift speed per unit field is called as the mobility of the charge carriers. Power, everybody knows, is V square by R. It's also I squared R. Now when to use when? Which formula? Use this formula when voltage is constant. Example, in parallel circuits. Parallel mein the voltage is constant. Use this formula when current is constant. So basically in series circuit. So that's when you are going to use this. Okay, so that's what you should remember. All right, great. Then which other formula is remaining? Yep. So let's talk about potentiometers also. Oh yes, Priyasa is saying that the battery is like, oh okay, fine. Let me just inform the admin who is basically taking care of this that the battery is low. Don't worry, I'll just mention it to them. Just 1 second. Thank you. Okay, I have informed the team, Priyasa. All right. Okay. All right. Great. Moving on to the next one. When you talk about batteries, there are 3 conditions in which you can use it. One is it's an open circuit. Second is it is basically discharging. It is discharging. And the third one, you should know that the current is flowing in, so it is charging. So 3 cases. So when it's open circuit, the voltage across the terminals of the battery is just E. But when the current is flowing out of the battery, so when I say it is open, the current is 0. So when current is actually coming out of the battery, then V will be E minus IR. And when current comes inside the battery, then V is E plus IR. Keep this in mind. It is E plus IR. E minus IR, E. Keep this in mind. Also, remember this formula. When you have batteries connected in series, okay, you can convert it into one single battery using this formula. The net EMF will be E1 plus E2 plus E3, like that, and the total internal resistance, the net, okay, will be just R1 plus R2 plus ... This is what you should remember. Similarly, if you have these batteries connected in parallel, something like this, then what will you do? The net EMF can be found out by E1 by R1 plus E2 by R2. You can have many terms like that, divided by 1 by R1 plus 1 by R2 ... This is the formula you will use. And when you combine it into one single battery, the net internal resistance will be just the formula for parallel. So 1 by R1 plus 1 by R2, like that. So use the parallel formula. That's it that you need to do. Perfect. Now, if you have taken a screenshot of this, you can move ahead then. All right. Now, we'll talk about meter bridge, potentiometer, voltmeter, ammeter. Quickly, let's go to Wheatstone and meter bridge. Now, Wheatstone's principle is applicable for capacitors, resistors, anything. So if you have resistors like this, okay, if you have resistors like this and you have a galvanometer, this is R1, this is R2, this is R3, this is R4, you have connected this across a battery, then the current through the galvanometer will be 0. That is called as the balancing condition. Balanced condition. That will happen when this by this. So R1 by R2, this by this is this by this, which is R3 by R4. This by this should be this by this. Then there is no current flowing here. You can forget this. You can forget this device completely. This is the exact principle on which meter bridge is based. So in a meter bridge, you have unknown resistance, known resistance, and a potentiometer wire which are triggered by an external voltage. You take a galvanometer and see at which point you get, zero current flowing through it. When this current is 0, then it is balanced, and then if this is R, this is X, this is L1, this is 100 minus L1. Use the same ratio formula. R by X will be L1 by 100 minus L1. That's the formula you're going to use. Why is it beneficial? It is used for finding the unknown resistance. Keep this in mind. Moving ahead, in voltmeters and ammeters, what happens? Moving ahead. So in case of an ammeter, what happens? You have a galvanometer which can handle certain amount of current, but if you want to increase the range of the galvanometer, what you do, you bypass the current through something called as the shunt resistance, and when that excess current comes, only a small current goes here, but most of the current flows through the shunt resistance. So the galvanometer has very little current flowing through it, and you use this device in series with the circuit. Usually this ammeter, if you talk about, this is basically the ammeter, this is not ammeter, this is ammeter, has very low resistance. This has very low resistance. Same thing in voltmeter, it's exactly opposite in case of voltmeter. So what you have the galvanometer, but you will have a resistor in series. You have resistor in series which has very high resistance, and this you connect it in parallel with the device. And that's what you will see. This is your voltmeter, and a voltmeter has very high resistance. What does a voltmeter do? Out of the current which flows in that circuit, a very small value flows through the voltmeter. Most of the current just flows through the device. Just by measuring the current and multiplying by the resistance, you can measure the voltage. That's what happens. Yep. Keep this in mind. Now, should you remember the formula for voltmeter and ammeter? The answer is no. If you are remembering the formulas for voltmeter and ammeter, that's the biggest mistake of life you are doing when you are studying this chapter. In fact, treat these problems like resistors in parallel and resistors in series. That's all. Treat them like series and parallel problems. It becomes very, very easy. Very, very easy. Is that clear? That's all. Okay. Now MD square is saying, sir, okay. So let me tell you, this is 1, this is 2, this is 3, 4. 1 by 2, R1 by R2, R3 by R4. This is the balancing condition formula. So balancing condition formula. Now, how does it matter whether it is 1 by 2 or 1 by 3? Even if I take R1 by R3, so even if I take R1 by R3, it will be equal to R2 by R4, even if you do cross multiply. Just take 3 here, just take 2 on the top. It's one and the same thing, just rearrange it. Okay, cool. Acha, chalo, koi baat nahi. Now, remember one thing, when you solve problems, what will be given? The galvanometer's capacity will be given. So if you know the current here, the current which can flow over here is 0.1 ampere. The current which is coming inside is, I don't know, maybe 9 amperes. So if 9 amperes is coming in, 0.1 amperes is going here. Obviously, 8.9 amperes is going here. Now, you know this resistance or this resistance. You can find the other resistance by just series and parallel formula. You don't have to remember anything. That's why I don't give any formulas. Same thing over here. The galvanometer will have some capacity, let's say 0.1 ampere capacity. You want to measure the total voltage range for, let's say, I don't know, 100 volts example. So if the question says what is the resistance which you connect in series, just think, if this is 100, this is also 100 because they are in parallel. And if this is 100, the total voltage will be current, which is 0.1, into total resistance, which is the resistance of the galvanometer plus resistance in series. That's it. V is IR. So you don't have to sit and by heart it. Just treat it like series and parallel. All right. Chalo, let's get moving. Questions coming up on your screen. Don't have to remember the formula. Like I just said, Burindun Miyaji don't spam, you'll get blocked. No need to by heart the formulas. If you are by hearting the formulas, then you have not learned the concept. Don't by heart it. So when power is V into I, when to use it? So when you know voltage and current both, and you are sure about both the things, then you use it. Okay, very rare cases. Alright, chalo, let's do the question coming up on your screen now. Quickly, let's see if we can do this. Potentiometer based question. Electric susceptibility and all that is not there. Yep, I just got my water. Thank you for reminding me. Yeah, I need it. Okay, come on. Let's do this. Let's do this. And we are going to learn all the concepts through the formulas. Sorry, through the problems. Oh yes, potentiometer also I'll do. Just, okay. Let me do one thing. Let me tell you about potentiometer and then let's come back to this. Okay, my bad. I forgot about potentiometer. See, here's the thing. When you have an external battery connected to a potentiometer wire, okay, this is how the circuit diagram usually looks like. This is generally your point A, this is your point B, this is essentially your wire, this is your supply voltage V, and what happens is, there are 2-3 things in this. First is potential gradient of a potentiometer wire. We are talking about potentiometer. So the first thing that you need to know about is the voltage gradient. How much voltage is there per unit meter? So it is volt per meter. So the length of the wire, if it is capital L, so it will be V by the length of the wire. As simple as that. Now, if you want to find the voltage between any 2 points, so the potential difference between any 2 points will be the voltage gradient into the distance between the 2 points. So if I tell you the distance between the 2 points over here is small l, what is the voltage between these 2 points? The answer will be nothing but voltage per unit length into small l. As simple as that. Make sense? Okay. Now, if by chance, whatever voltage difference is there between these 2 points is the same voltage between any device over here of some other circuit, let's say it has the same voltage difference. So then, if you connect this and if you connect this over here, do you think any current will flow? I'll repeat. There is some voltage difference between these 2 points. You take another device of some other circuit and by chance it has the same voltage difference as these 2 points. So if you connect them, will there be any current flowing through this? The answer is no. Hence, that is called as the balancing condition. So when it is balanced, then the current is 0 because this potential difference and this potential difference exactly matches. That's it. Perfecto. Now, the applications of this are very interesting. So first way is basically when you compare EMFs. So first time you connect a battery and then check the balancing length. It is L1. Next time you connect another battery and you see what is the new balancing length. So that can be used for comparing EMFs. So when you connect a battery of EMF E and resistance R, current is 0. So understand, when current is 0, I just told you the voltage difference is just the EMF of the battery. So just put delta V as E. So you'll get E is equal to V by L into small l. That's it. This V is this V, voltage between these 2 points. Okay, so you will just get this. And if you have 2 such batteries, so you will get E1, you will get E2. If you take the ratio, what will you get? V and L are constant. So you will just get L1 by L2. What you will get? You will just get L1 by L2. Understood? Got it? Perfect. Very good. So this is the application of a potentiometer and this is how a potentiometer works. Now I think you will be able to solve this question. Chalo. So here it is. Their length of the wire of a potentiometer is 100 centimeter. The EMF of the standard cell is E volts. It is employed to measure the EMF of a battery whose internal resistance is 0.5 ohms. The balancing point is 30 centimeter. The positive end is obtained at 30 centimeters from the balancing length is obtained at 30 centimeters from the positive end. What is the EMF of the battery? So this is just the direct application of potentiometer. Let's see what is happening. So you have a standard cell of E volts. So this is E volts, let's say, and it is connected to a potentiometer. So this is point A, this is point B. You have to measure the EMF of another battery. This battery's EMF, I do not know. I'll just call it as EMF. I don't know. This is some internal resistance. What have you done? You take this wire here, you take this wire via galvanometer and connect it at this point. It is given in the question that the balancing length is nothing but 30 centimeters. The total length of the wire is 100 centimeters. Okay, so the total length is 100 centimeters. So the question is, what is the EMF? Guys, I just told you, when the current is 0, the voltage difference across these 2 points is just E, because no current. And we also know delta V is voltage gradient, volts per meter. What is the volts? E volts. Per how many meters? Basically this is 100 centimeter. This is your voltage gradient into the length. What is the length? 30. So just put this delta V as EMF, you will get the answer. So EMF of that battery will be 0.3 into E. That's it. 0.3 into E is the answer. Very good. Understood. Got it? Understood? Perfect. Yeah. So this is how you apply potentiometer formula. So the potentiometer formula, voltage difference is EMF, which is applied across the 2 ends divided by the total length, which is potential gradient, into the balancing length. Kuch nahi hai, there is nothing great about it. Very good. Let's get going to the next one coming up on your screen. What is the mobility of this charged particle? Come on, let's do this. Okay. What is the voltage gradient? I think you missed the starting part. Okay. Did we miss Kirchhoff's law? Well, I deliberately left it off because, that is probably we can do it in the form of application. I'll just show you one question. Wahan par I will show you how to use Kirchhoff's law. So if I just tell you KVL, then you will not understand it. There is one question coming up. There I will show you. Okay. So what is the mobility of this charged particle? Come on. Let's see if we can do this. Okay. B, sure. Mobility. Mobility is nothing but drift speed by electric field. Drift speed. How much is the drift speed? 7.5 into 10 to the power minus 4. What is the electric field? Electric field is 4 into 10 to the power minus 12. So it will become 7.5 divided by 4 into 10 to the power 8. So 7.5 by 4, it will be almost 1.8 times. So I think it should be option D. Correct. Perfect. Very good. Let's move ahead to the next question coming up on your screen. This question I will explain you KVL and KCL. Yes. Now there is a current of 6 amperes which enters from the top. Equilateral triangle. PQR having 3 wires of resistances this. Then what are the currents I1 and I2? Okay. Now a lot of students will think that we should use KVL, but I'll tell you, you don't need KVL. But after solving the question, I'll tell you what is the meaning of KVL and how to apply it in general, just in case you need to use it. See, this circuit is nothing but equivalent to, observe, there is one branch here, other branch here. There are no more branches. So just think of it like this. There is a resistor here. There is one branch here. There is another branch here with 2 resistors. That's it. So this is 2 ohms, this is 2 ohms, this is 2 ohms. Now from here 6 amperes of current is coming. Here I1 amperes, here I2 amperes. What happens in parallel? In parallel resistors, the voltage is same. Voltage across these two, is same. And voltage is I into R. So current into resistance is constant. So what is the current into the resistance? It will be I1 into 2 plus 2. Current into R. And on the other side, look at this. What is the current? It is I2. So I2 into how much is the resistance? It is 2. So basically I1 or 2I1 is I2, or think of it this way, I1 by I2 is 1 by 2. I1 by I2 is nothing but 1 by 2. So the currents are getting divided in the ratio of 1:2. How do you divide 6 amperes in 1:2? 6. How do you divide it into 1:2? Obviously, 6 you divide it into 3 parts. 2, 2, 2. Take this one here and then take these two separately. So this is 1:2, right? That's it. This is 2 amperes. How much is this? This is 4 amperes. So hence the answer will be 2 amperes and 4 amperes. Got it? It's not B, it is A. Be careful. It is A. 2 amperes and 4 amperes. Yep, just check this out. It is option A. So just had to divide it. Now what is KVL and what is KCL? See, here you can first understand KCL. Whenever you have a junction, whatever currents come in and whatever currents go out, they should add up to be equal. So the current which is coming in, which is 6, should be equal to I1 plus I2. And it makes sense. We got I2 as 2 amperes, I2 as 4 amperes. Correct. It always has to be true. So whatever current is coming in should be equal to current which is going out. This is Kirchhoff's current loop, Kirchhoff's current law. This is applied only at junctions, the nodes. So that's why it is also called as the junction law, at the nodes, at the point of intersection. Now, the next thing that you should know, okay, now the next thing that you should know is the Kirchhoff's voltage loop law, KVL. Now what is KVL? KVL just says the sum of all the voltage differences is 0. There are certain rules you need to follow. If you are going through a resistor and let's say the current is like this, and if you go in the direction of current, and if you are going in the direction of the current, then the voltage will fall by IR. The voltage falls in the direction of the current, it drops by IR. But if you go like this, obviously it will increase. You are going opposite to the current, it will be plus IR. Same way, if you are having a capacitor, this is plus charge, this is negative charge. Remember, Q is CV. Okay, the capacitance is C. If you go from the positive to the negative charge, think high to low, positive to negative. So it will drop. So it will be minus Q by C. That will be the drop of the voltage. But if you go from negative to positive, then obviously it will be plus Q by C. Plus Q by C. Got it? Similarly, if you have a battery, doesn't matter what the direction of the current is, if you are going from negative to positive, okay, if you are going from the negative to positive, minus to plus, it is going to increase. So it will be plus E. And if you go from plus to minus, it will be minus E. That's all. If you remember these rules, then it becomes easy to apply any KVL loop law for any loop. Okay, so let's say for example, you apply Kirchhoff's voltage law for this particular loop. So let's start from P, go to Q and R and then come back. So what is my loop? P, Q, R, P. From P to Q, I am getting this resistor. In the direction of the current, drop. So how much? Minus I1 into R, which is 2 ohms. Okay. Next, from Q to R, I think the same current is flowing, I1. So minus I1 into R, because again I am going in the direction of the current. Next, from here to here, opposite to the direction of current. So plus I2 into R. Came back to the same point. This is 0. This is how you apply it. Very good. Let's get moving to the next one. Perfecto. 2 amperes and 4 amperes. Here is the next question on meter bridge. Yeah, just 2 rules. Cyber piece, I just explained to you the sign conventions right over here. Just watch it. So remember one thing, whenever you increase the potential, na, it is positive. Whenever you go to a lower potential, it is negative. As simple as that. That's it. Do this question. Come on, quickly. Chalo, figure this out, my warriors. What is the value of unknown resistance out here? Chalo, figure this out. Option A, sure. Think again. Right? Pakka? So this by this is this by this. This is 40. So how much is this? This is 60. Good? Okay. So 65 by R. 65 by R will be 40 by 60. So 0, 0 goes. This will become 2. This will become 3. So R will become 3 into 65 divided by 2. So 65 into 3 will be 195. 195 divided by 2 will be how much? Yes, 97.5. That's the answer. Perfect. Very good. It's not C, it is A. Some of you made a mistake. Be careful. Okay. Yeah, tomorrow we'll be doing only questions. Today is theory plus questions. Correct. Moving on. 12 cells of EMF 2 volts are connected in series. 3 are connected opposite. Then what is the new EMF? What is the new EMF? Come on. Ahari, I did theoretical questions in yesterday's class, assertion, reason. They were all theoretical, conceptual based. Okay. And also case study based. So today's lecture is based on formulas. It's completely a formula revision class. Okay. So right now, Akshaya, we are with current electricity. We'll start magnetism now. Be careful. Don't make any stupid mistakes right over here. 12 cells of 2 volts each. But 3 are wrong. That means 12 are there, right? So 9 are correct. 9 are correct. 3 are opposite. So the total EMF will be 9 into E minus, because it's opposite, so 3 into E. So it will be 6E. E is nothing but 2, so it will be 12 volts. B option is correct. B option is correct. Very good. Perfect. Excellent. A lot of students do this mistake. So they see, oh, there are 12 cells, 12 into E, 3 are wrong, so minus 3. So the answer will be 9E. So this is wrong. Okay, this is wrong. Okay, let's get moving to the next one. External resistance is given and internal resistance of the cell is also given. What is the potential difference across the terminal? Figure this out. What is the potential difference across the terminal? Come on. And internal resistance is equal to the external resistance. That's what the question says. So we have this battery, internal resistance, external resistance, E, R, capital R. There will be some current which is flowing in the circuit. There will be some current which is flowing in the circuit. Okay. Now the question is, what is the potential difference across the terminals? Look at this. The potential difference across the terminals. Can I not say it is E minus IR, because that's our standard formula? So that's it. Just use that now. What is the current? The current will be EMF by total resistance. Total resistance will be R plus R. Why? Because here it says internal resistance is equal to the external resistance. So it is basically E by 2R. So the voltage difference will be E minus I, which is E by 2R into R. R goes. So E minus E by 2, which is E by 2. So which is option A? Which is option A? It is not B. Be careful. It is option A. Many of you got it wrong. Yes, be careful. Yeah, it is easy, but a lot of students have made silly mistake. Option A is correct. Going to the next one. Going to the next one. So Rupa, please remember this concept. Whenever you have a battery, whenever you have a battery, this also has some internal resistance. So that voltage of the battery is E minus IR when the current is coming out of it. So that's what I have used. So I have first found out the current. Once I found out the current, I put it back, and that's how I found out voltage. Okay, chalo. Next question. All right. Divjot, I will take it up tomorrow. Okay, I'll definitely take it up tomorrow. I'll have a look. Two different materials, two different wires. What is the ratio of the resistance? Let's see. R is rho L by A. So R1 by R2 will be rho 1 by rho 2. Everything is given. L1 by L2, but A2 by A1. Rho is 3:4. 3 by 4. Length is 2 by 9. Area is 8 by 27. So 8 by 27. Be sure that 8 is below, 27 is on the top. 4, 3, 3 3s are 9, 4 4s are 16. That's it. Perfect. Perfect. B. Very good. Now, let's go to the next question. Oh, now we are going to have a break. But before that, let me quickly tell you. We have finished electrostatics, Gauss law and current electricity problems. After the break, we'll start with magnetism and then go to EMI. So 15-minute break, and also it's a good time that we congratulate all these toppers from Vedantu this year who have made us proud, because there were more than 9% students just in top 10,000 ranks for JEE mains. 6% of the students who entered IIT were from Vedantu, and there were more than 1,500 ranks from JEE Advanced. So if you want to start your journey for JEE, if you are confident, if these questions look too easy for you, then I would suggest please go ahead, join the crash course, compare your scores with the toppers, with even previous year's toppers, and also you'll get assignments and live classes with recordings. So there's a link in the description box, you can definitely check it out. So we'll take a break, because after the break we are going to start with moving charges and magnetism. Okay, so that's our next chapter. Yep, that is it. Okay, cool. So let's go with magnetism. After a short break, I'll start the timer for maybe around 10 minutes or something. Okay, shall we have a break for 15 minutes maybe? Okay, so we'll have a break for 15 minutes. Let's start the break. All right, cool. Chalo. Yo, welcome aboard. Join in, join in, join in. Yes, so we had a 15-minute short break in this formula revision session. Those of you are joining in a little bit late, let me tell you, we have completed electrostatics, we have completed Gauss's law, current, electricity, problems and formulas. So now we are going to do magnetism and then we will do EMI. So get ready for it and let's start seeing the formulas on magnetism. Yep. Oh my god, Ibn got scared. Vanakkam, everyone. Chalo, let's get going. So what do we have? First of all, yes, moving charges and magnetism. Let's talk about this. So first of all, I want you to remember about, okay, so whenever a charged particle, it is moving with velocity v, and let's say there is some magnetic field B, then the force acting on it due to the magnetic field is given by QV cross B. Very important to know the force is perpendicular to velocity. That means the work done is zero. That means the energy remains constant because the force is always perpendicular to no matter where the velocity is. So work is never done. So it can only change the direction. And let's say you also have some electric field, then you also have one additional force which is charge into field. So together they are called as Lorentz force, right? So this is the Lorentz force which you need to remember. Now there are special cases which you need to remember as well over here. So if the magnetic field is like this and the charged particle is thrown perpendicular to the field, charged particle is thrown perpendicular to the field, then it goes in a circular path. The radius is given by mv by qb. You can also remember mv is momentum, so that's divided by qb. Not just that, the time period, 2 pi m by qb. In your NCERT, omega is given. Omega is same as 2 pi by t. You can rearrange and get it. So time period is 2 pi m by qb. And the next thing that you need to remember is if the magnetic field is this way and you are throwing the particle at an angle, then what happens is it goes in a helical path, and this is called as the pitch of the helix, and the time period is same, be it this or this, because speed does not matter. Speed has no role to play in the time period, so the time period is the same. The pitch can be calculated by the horizontal speed, which is v cos theta multiplied by the time period. That's something which you should know. Everybody fine till here? Cool? Yes. Chalo. Mridu Varchni, I am at home and I am conducting my classes from my studio, which is at home. Welcome, welcome Aniruddha GK, thank you. Okay. Very good. Now, Veera, you don't have to use Fleming's rule as such. Everything in magnetism or electrostatics, whatever, remember, whenever you have cross product, use your right hand thumb rule. Okay, right hand thumb rule. So if there is A here, there is B here. So which is the first vector? A. Second vector B. So first, if A vector is here and let's say B vector is here, point your fingers in the direction of A, move it towards B, automatically you will get the direction of A cross B. Don't remember, sir, this is B, this is I, this is L. In EMI, this is V, this is L, this is B. No, you will get confused. So remember right hand thumb rule, don't have to remember Fleming's rule. Okay, so if you remember the formulas, you will get it. Next, if you have a wire, okay, which carries some current and you take some element L and this wire is placed in some magnetic field, let's say B, then also it will experience force. It is IL cross B. So don't have to remember ILB rule separately with your fingers marked. IL cross B. Length is here, okay, that side. Magnetic field is inside. Length, use your right hand, length cross B. See where your thumb is? That side. So obviously the force will be like this. As simple as that. Clear? It's very easy. Cool. Moving ahead to the next one. Very good. Will the physics paper be easy? I don't know, bacha, if it will be easy or difficult, but we are preparing for every case of eventuality, no matter what happens. Next important thing is, if there is a charged particle of charge Q and mass M, and let's say there is electric field and let's say there is magnetic field. This is called as the crossed field, where velocity perpendicular to electric field, which is also perpendicular to magnetic field. All three are perpendicular: velocity, electric and magnetic. That is called cross field, and this velocity will remain constant only if it is equal to E by B. If it is E by B, because when this condition is met, what happens? The force due to electricity and the force due to magnetic field both cancel out each other, so the net force is zero. So that is a special condition which you should remember. Keep this in mind. Next, if you have a wire which carries current and you are at certain distance r, it produces magnetic field around it. So it will definitely produce magnetic field around it, and you can find how much is that magnetic field by Biot-Savart's law. Okay, so Biot-Savart's law will give you the magnetic field formula. What is the formula? Mu naught by 4 pi I dl cross r hat divided by r square. Very similar to electrostatic field. Constant into some quantity which creates the field into that r hat is there. In electrostatics that cross was not there. Here you have r square. So this is the formula. Now what is the value of mu naught by 4 pi? That is 10 to the power minus 7. Perfect. Keep this in mind. Okay. Now if you are confused about the directions, let me do some simple conceptual questions for you. If the current is here, okay, it is going to create magnetic field around it like this. So think curled fields like that. So when the fields come here, they go inside the plane of the board here. So the field is inside here. They go inside, come from behind. So they are like this over here. So this is how you can find the direction of the field. Very simple. Hold your thumb in the direction of current, curl your fingers. The curled fingers give the direction of the field. Similarly, if there is another wire, let's say it is going like this. This is the current. Hold your thumb in the direction of current. Curl your fingers. See how your fingers are getting curled? They are getting curled like this. So when it comes from behind, it will come towards you. They'll go like that and go inside. So this is cross. Is that clear? Very easy. Great. Chalo. Let's get moving to the next part. Now fields due to different geometries. You should know the formulas. First thing, if you have a wire which carries current I, the radius is r, and you are on the axis at a distance of x. What is the field at that point? The field at that point, this is how the field will be over here. So the field at that point will be mu naught current, okay, and then you have r, which is the radius, divided by 2 is there, and you also have r square plus x square raised to 3 by 2, and this is r square. Everything is r square, r square, r square, x square. Keep this in mind. And in a special condition, when you are at the center, okay, so when you are at the center over here, so x is equal to 0, that will become mu naught I by 2r, standard formula. Okay, very, very simple. And let's say there are many turns, there are many loops over here, so then just multiply by n if there are many turns. That's it. Very good, very good. Okay, so we'll complete this formula revision and then we'll go to the problem solving. Yep, don't worry. Yep, we are going to go to the formula revision. Then Just like you had Gauss's law, you have Ampere's loop law. You should just at least remember the statement of it. So if you have currents I1, I2, I3 like this, and let's say you go across a path which encloses some currents, you travel some distance dl, 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 dl and come back to the same point. At every point there will be some magnetic field. You find what is B vector dot dl. Go to the next, find B dot dl. Keep adding it, that means sum it up. Because you are coming back to the same point, cyclic integral. This comes out to be mu naught into enclosed current. Now whenever you calculate enclosed current, it's those current which pierces through this particular loop that you have taken. In this case it is I1 and I2. But be careful, one is positive, one is negative. So they will not add, you will have to subtract them if the directions are opposite. Is that clear? Okay, is that clear? But remember again the same thing. This field is because of all the three, 1, 2 and 3. All the three cause this field. This is because of everything. But here this enclosed is only because of 1 and 2 only. That's it. Perfecto. Keep this in mind. Now, the next thing that you need to remember is a field due to straight wires. So, field due to straight wire at any point will be mu naught I by 2r. This is the formula. But I hope you have seen that question which I had marked yesterday, an important study. If you are inside that wire also there is field. Yes, the wire itself has some radius and inside the wire as well there is magnetic field, and depending on how far you are from the center, the field changes like this. Mu naught, same thing, I by 2. Instead of small r, you have capital R square and small r goes on the top. So that's the change when you are inside. So this is for inside and this is for outside the wire. Keep this in mind. Very, very important formula. Next thing, the Ampere से करने की ज़रूरत है. So md square, if you can solve the question with Biot-Savart's law, so you don't need amperes. If you can solve it easily via amperes, then you don't need Biot-Savart's. They both are interchangeable. You can use it one instead of the other as per your convenience. Next is solenoid. Solenoid ka field. What is the field inside a solenoid? If it is a long solenoid, then the field is mu naught Ni. Remember what is this N over here? This N over here is turns per unit length. Small n is turns per unit length. And if you have a toroid, it is essentially a solenoid. Then also you can find out the magnetic field inside that toroid, and that will be exactly the same. It is mu naught Ni. This N is total turns by total circumference, which is 2 pi r. So if you are wondering what r is the radius of the toroid. Okay, so keep this in mind. So remember one more thing, that the field outside the solenoid or the field outside the toroid is not there. Okay, it's negligible, it's hardly anything, hardly any field lines leak outside, so it is negligible or it is not to be accounted for outside the toroid or outside the solenoid. Fair enough. Next thing that you need to remember is the force between the wires. So if you have two wires which carry current, the force, this is I1, this is I2, then there will be some force between them. Okay, now if they are in the same direction, they will not repel, in fact they will be attractive, so they will attract each other. So that force is given by, what is the force value? Oops. Yeah, so it is given by mu naught I1 I2 into the length of the wire divided by 2 pi into d. D is the distance between them. Remember, same directions. If they are same directions, then they will not repel, they will attract. And if they are in opposite directions, then they will repel. It's exactly opposite of electrostatics. That's what I want you to keep in mind. Fair enough. Okay, very good. Now also remember, a loop of wire which carries some current, it also produces a dipole moment. This is very much similar to a bar magnet with north and south pole, which has a dipole moment like this, just like electric dipole moment. And this M is given by number of turns into current into area. Number of turns into current into area. And if you place this dipole in external field, then it will experience a torque which is given by M cross B. Very similar to P cross E. Dipole moment cross electric field gives torque. Same thing in magnetism. Even energy formula is same. It is minus M vector dot B vector. So this dot is nothing but cos. This cross is nothing but sine. Keep this in mind. So the energy is minus M dot B, and remember the reference energy is 0 when theta is 90, because cos 90 is 0. So you always measure energy when angle made by that magnetic moment is 90 degrees with respect to the field. Keep this in mind. Okay, these are all very important formulas which you should know. Last thing before we actually start doing some problems, is nothing but if you take a charge and if you move it in a circle, this is equivalent to a loop. Okay, so this is the path. This is the path taken by this. It is moving with some angular speed. It is equivalent to a loop which carries current. That's it. And this current can be calculated easily. It is charged by the time period. Time period will be 2 pi by omega. As simple as that. And because it is equivalent to a loop carrying current, hence it will also have some magnetic moment. And there is a very easy formula to remember this. Magnetic moment by angular momentum is charged by 2 times of mass. This is magnetic dipole moment. This is magnetic dipole moment. This is angular momentum. What is this? This is angular momentum. Keep these formulas in mind. It will help you if there is a charged particle which is rotating. Okay, very good. Chalo. Then what else do you have? Okay, so this is one thing. Then yes, you have galvanometer. Let's talk about galvanometer. So in a galvanometer, okay, this is, let's say, 0, there is some deflection and there are magnets. You have the north pole, you have the south pole, you have that coil. The coil will get affected because of the magnetic field, and the coil has some current which is flowing in it. The coil has some current which is flowing in it. It deflects based on the current. There is a spring which is attached, if you remember, which prevents its rotation completely. So when you remove the current, the spring action pulls it back to 0. The needle deflects depending on how much current you pass. So you should know about the deflection theta. Remember, I have told you about basketball. Basketball means NBA, and there is a captain of basketball team. So captain, this is multiplied by current. So theta, deflection, is NBA by current, constant of torsion into I. What is this C? This is nothing but your torsional constant. Keep this in mind. Torsional constant. Some books have the symbol as K. Yeah, some books will use the symbol as K. That is also okay, guys. Yeah, that is fine. That is no problem. Okay, let's do some questions based on this then. Chalo, let's start. Perfect. So let's do some questions. Will energy and momentum be conserved in uniform circular motion? Yes. In general circular motion, maybe, may not be, Ayushi. Okay. Yes, Vedika, I do teach 11th also. My nurture series are there on this channel. There is a loop of magnetic moment M. Its orientation is given. Okay, let me just refresh this 1 second. Yep. Okay, so the orientation is rotated by changed by 30 degrees about an axis perpendicular to the plane. So what is the work done in this case? B, C. Interesting. B or C. Amir, I did conversion of galvanometer into ammeter and voltmeter in current electricity. So just rewind the session back. I have just done it. Okay, I have done it previously, just half an hour or 1 hour back. Okay, now see, this is a circular loop which will have some magnetic moment to rotate the loop by 30 degrees about the axis. This itself is the axis. Maybe there is a magnetic field like that. Please remember, it's given in the question, it is rotated about that axis. That means you have rotated it like that. So when you rotate it like that, this angle is basically constant. So u, which was minus mb cos theta, this theta is constant. So u is constant. So delta u is 0. So work is 0. So the answer is D. Yeah, some of you now got it. Very good, Rishabh. It is not mb or root 3 by 2 or by 2. Be careful. It has been rotated like this about the axis. You will lose marks. It has not been turned this way. Okay, moving to the next question. When a charge of 1 coulomb, which moves with this much speed, normal to the field, experiences 100 Newton force, then what is the magnitude of the magnetic field? Okay, so Tarun, it was rotated about the axis. Magnetic moment did not change with field. So theta did not change. How will u change? Potential energy. It will not change. So that's it. Think carefully. It has been rotated about the axis in the previous question. What is the magnitude of the field? Very easy question. Use the formula for Lorentz force. So F is Q V B, and it is given that it is moving normal. Normal means theta is 90 degrees. Okay. So force is 100, charge is 1, velocity is 10 to the power 6, B is 10 to the power minus 4, correct? Which is Tesla, which is 1 Gauss. So the correct answer is 1 Gauss, option A. No, it is not B. It is not B, it is 1 Gauss. Be careful. Yeah, many of you made a mistake there. So be careful. So that conversion is important. 1 Tesla is 10 to the power 4 Gauss. 10 to the power minus 4 Tesla will be 1 Gauss. Gauss is a smaller unit. Okay. Chalo, let's get moving to the next one. There is a coil of radius 10 having 100 turns, carries this much current. The field at the center of the coil is how much? What's the field at the center of the coil? Let's apply the formulas and see if we can get this. So current is given, turns are also given. What is the field at the center? We know which formula to use. B is mu naught I by 2R. Chalo, use this fatafat. How much hand formulas are there, Gunesh? The only one right hand formula. That's it. There is nothing else that you will need. Yeah, that's all you will need. Okay, cool. Chalo, let's see quickly. Find this out. What is the meaning of induced? Hanishma, I will come to it when we talk about EMI. So just hold on. We are going to EMI in a bit. Figure this out. So mu naught is what? 4 pi into 10 to the power minus 7 current. What is the current? 3.22 into radius. What is radius? 10 centimeter, which is 0.1 meter. Okay, this will go like this. So 2 into 3.2, 6.4 pi into 10 to the power minus 6, I guess. Just check this out. Yep. Anything else? Oh, but we have also 100 turns. So into 100. So when I do it into 100, this minus 6 will become minus 4. So 6 3s are 18. So it will be slightly more than 18. Just check this out. Slightly more than 18. So that will go to 20. So 20 into 10 to the power minus 4. So 2 into 10 to the power minus 3. Around that. Just check this out. Option A. Perfect. Perfect. Don't skip this chapter. This chapter is easy. Like you can see, directly formula based questions are there. Direct. Okay. Moving to the next question coming up on your screen. Infinitely long wire, loop and wire. What is the field at the center? That's the question. Let's try and solve this. So first of all, due to this wire, use your right hand. Put your right hand thumb like this. The fingers curl this way. So the field is this way. So basically, if you think about it, at point O, the field is coming towards you. How much is that value? Mu naught I by 2 distance from the wire. Think of this like a long wire. So field due to a wire, how do you calculate? Mu naught I by 2 distance, which is, sorry, 2 pi r. 2 pi r, that's it. That's the formula. But this loop, it will also produce a field. The current is going like this. So the field is going inside. So there will be a cross. So the field due to that will be just mu naught I by 2r. This is due to the loop. Remember, for a circular loop, there is no pi. For a wire, there is a pi. And you can see one is outside, one is inside. So it should cancel. So I think minus sign should be there because they are opposite to each other. So option C will be correct. Yep. Understood? Got it? So you can see mu naught I by 2 pi is common, and that pi, after taking LCM, you get pi minus 1. Perfecto. Got it? Very good. Very good. Moving on to the next one. Solve this next question. A solenoid of 1.5 meter length and 4 centimeter diameter has this much turns per centimeter. Current is this much. What is the field inside it? So the question is on solenoid. We have the solenoid. Question is, what is the field inside the solenoid? Come on, let's do this. B will be mu naught Ni. Mu naught is 4 pi into 10 to the power minus 7. Turns per unit length, 10 turns per centimeter. 1 centimeter is 10 to the power minus 2 meters. Into what is the current? The current is 5. What is the use of this? No use, just ignore it. So let's see, 4 5s are 20. So 20 pi into 10 to the power minus 7 into, this will become 10 to the power 3. So this will become 2 pi into 10 to the power 4, and this will become minus 3. Just check this out. 2 pi into 10 to the power minus 3, which is option A. Are you getting option A? Very good, make it unique. No issue, it is not C. Be careful. Yeah, it is option A, bachalo. Be careful with the units. The second option said Gauss. Gauss is different. Yeah, be careful. Chalo, let's move to the next question. A galvanometer is there, gives full scale deflection for this current. To use it as an ammeter of 10 amperes range, what should be the shunt resistance? That's the question. I told you sometime back, whenever you see ammeter question, think of it like resistor problems. Don't get confused and don't try to recollect the formulas of ammeter. So this is your galvanometer of 100 ohm resistance. Because you are using it as an ammeter, so you need a shunt resistance like this. Now the galvanometer has a full scale deflection for 10 milliamperes. That means the maximum current which can go through the galvanometer is 10 milliamperes. But when you pass 10 amperes of current from outside, so when you pass 10 amperes current from outside, then it gets divided. 10 milliamperes goes here, the rest of it will go over here. So this will be 10 minus 10, 10 to the power minus 3. Guys, this is a very, very small number. So I can approximately say most of the current, 10 amperes, goes from the other side. Correct? And now we know these two resistors are in parallel. So resistors in parallel, voltage is same. So IR is same. So just do that. Current into resistance. 10 into resistance is current into resistance, which is 10 into 10 to the power minus 3 into 100. This 0 goes. So RS will be 10 to the power minus 1, which is 0.1 ohm. Where is 0.1 ohm? Option B. See if you guys got it? Yep. So what did I tell you? Always treat ammeters and voltmeters like series parallel resistors. Don't remember the random formulas. 1 Gauss is also unit of field md square, but 1 Gauss is 10 to the power minus 4 Tesla. It's a unit, just like Newton, erg, joule, dyne, centimeter, meter. It's a unit, that's it. Next question. There is a current which is flowing in a wire. Force this much acts in the field. The angle between the field and the current is. Okay, let's see. Hanishma, Tangdu, you can do one thing. You can just message me on Instagram. I'll let you know what to do. Okay, just message me on Instagram. Fair enough. So we have a wire which carries current. Okay, and it is placed in some field, and the field makes an angle of basically, I don't know how much, but there is a force acting. So I know which formula to use. ILB sine theta. IL cross B. What is the force? The force is 15. What is the current? The current is, where is the current? 10. Okay. What is the length? The length is 1.5. What is the field? Field is 2. Sine theta, I don't know. 1.5 into 10 is 15. This is also 15 into 2 into sine theta. So 15 goes. So sine theta, take that 2 below, it will become 1 by 2. Whose sine theta is half? Obviously theta is 30 degrees. That's it. Done, done, done. This is how you apply formulas. Very good. You guys are getting it. These kind of questions are going to come in physics exam, and you are going to be like, sir, we know this already. We have attended your classes. This is so simple. You should get full marks for sure. An electron beam which travels with this much speed perpendicular to the field of this much intensity, the radius of the path of the electron is how much? What is the radius of the path? Come on, let's do this question. So the radius is mv by qb. So whenever you take a particle and throw it perpendicular, it goes in a circle, uniform circular motion. The field is like this. So this is the radius. So just substitute the values, you should get the answer. Okay, what and all do we know? Mass. Mass is 9 into 10 to the power minus 31. What is the velocity? Velocity is 1.6 into 10 to the power minus 7. What is the charge? It's an electron. So 1.6 into 10 to the power minus 19. B is 0.1. You can see certain things get cancelled like 1.6, 1.6. So it should be 9 into 10 to the power something. Okay. So 9 is already there. So just need to figure out the power. So let's see if we can do this quickly. 10 to the power minus 31 minus 7. This will go on the top. It will become plus 1. And this will become plus 19. Chalo, see how much is this power? 10 to the power 19 plus 1, 20. 20 minus 7. Come on guys, do this. How much is it? C for sure. Pakka. Very good. Very good. Yeah, the velocity. Ooh, I did a mistake. Yeah, my bad. Thank you for pointing this out. This was plus. Yes, this was plus. So sorry. Okay, so 19 plus 1, 20. 20 plus 7, 27. 27, and this is minus 31. So this should be minus 4. Check this out. Yep, option C should be correct. Done, done, done. Let's move ahead. Let's go to magnetism. Wow. Yes, it is, Aditya. I just made the change as plus 7. Yep, I made it. Okay. Magnetism and matter. There are only 2-3 things over here, and then we'll go to some questions. Okay. So what are the questions and what are the formulas? So let's start with the formulas. So first of all, I would like to tell you about the Gauss's law in magnetism. So Gauss in magnetism. See, magnetic field lines are always loops. So this is a magnetic field line, right? It's always loops. It always completes its path. It never starts or ends. So if you calculate the flux through a surface, if you calculate the flux through a closed surface, then the answer for that will be always 0, because whatever flux is going in will always be the flux which is going out. This is called as the Gauss's law of magnetism, because the net flux through any closed surface, no matter how you take it, is always 0, because the field lines are circular. So whatever comes in should go out. Keep this in mind. That's the first thing that is there in the chapter. Now, is that okay, guys? Fair enough? Very good. Now, the most important thing where people get confused is over here, the dip angle and all of that. So listen to me carefully. See, you have a bar magnet or a needle. Let's say this is the north side, this is the south side. It will point, the magnetic moment will always point in the direction of the external field. even if you try to tilt it, it will try to come back because of the torque, M cross B torque. Now, this B is basically the Earth's magnetic field. The Earth's magnetic field. The Earth has two components of field at any place. So if you are here, okay, then the Earth's magnetic field has two components. What are the two components? Because the Earth's magnetic field might be at an angle at any given place, there is one component which is called horizontal, the other component which is called vertical. This is basically your dip angle, delta, theta, whatever you want to use. This is called as your dip angle. Basically, it just talks about, what is this? Tan of delta will be vertical, which is BV by BH. Also, BV square plus BH square is B square. Standard. Yeah, standard vectors. Now, understand this B is in a plane called as the magnetic meridian. This plane is called as magnetic meridian. In fact, when you see from the top, this magnetic meridian is like this. So if that person is standing here, this is basically your magnetic meridian. The same thing over here. Okay, from the top it's like this. But if you continue your journey along the field, okay, if you continue, what you will get, you should get the pole of the Earth, right? If you continue going in the direction where the compass needle is pointing, in the direction of the plane, you should get to the pole of the Earth. But you don't get the pole of the Earth. What pole do you get? You get the magnetic pole. Magnetic pole. The reason for this is, if you think about the Earth, this is the axis. The magnetic poles are somewhere else. The poles are not where the axis meets the Earth. It is somewhere else. So you will go to the magnetic pole because that's where the magnetic properties are. The Earth's actual geographic pole is somewhere else. So for that you need to go in a slightly different direction. It's not much different, but yes, it is there. So try and understand this. If you actually want to reach the Earth's geographical pole, then you might have to travel in some different direction. Maybe like this. So if you continue your journey like that, maybe then you will get the pole which is called as the actual geographical pole of the Earth. Do you understand now the difference? And yeah, so the pole of the compass always points towards the magnetic pole, not the geographic pole. It points you towards magnetic pole. Magnetic pole is slightly to the north of Canada and somewhere in Antarctica. That's what it is. So this difference in the angle, this is called as your declination angle. What is it called? It is called as the declination angle. Keep this in mind. So I hope now you are clear what is the dip angle and what is the declination angle. Is that okay? Everyone, shall we go ahead? Okay, cool. Let's do this. There are two different places. The angles of the dip are respectively 30 and 45. And these two places, the ratio of horizontal component of Earth's field is how much? Okay, let's start with a diagram. Okay, let's do this. This is B, this is BH, this is BV, and this is your dip angle, theta, delta, whatever you want to call it. Okay, inclination angle is the angle which it makes with the horizontal. It's basically in a way dip angle itself. Okay, the angle which it makes with the plane, with the horizontal plane. That's it. Okay, so that's inclination. Dip angle is almost the same. The only difference is that in inclination can be in any given plane. You can have it in magnetic plane also, this plane also, or some other plane also. Dip angle is generally in that magnetic plane only. Okay, so what do you need to do? See, B is same at both the places. Earth's magnetic field is same. The question is the ratio of horizontal. Acha, BH is B cos theta. So BH1 by BH2 will be cos theta 1 by cos theta 2, because B, like I said, is same. So it gets cancelled. So cos of 30 by cos of 45, cos 30 root 3 by 2, cos 45 1 by root 2. So this will become root 3 by root 2. Is it there somewhere? Yes, it is. Perfect. AMD, the Telegram link is there in the description box below. And yes, if you have a doubt in capacitance, just leave it in the comment section. I'll respond to it. Okay, Kirti Vasan. Moving on. BH is given, BV is given. What is the Earth's total field at that place? What is the total field of the Earth's magnetic field at that particular place? Come on, my warriors. Chalo. Let's see. BH is given, BV is given. We all know that they form a triangle. This is BH, this is BV, this is B. B is root of BH square plus BV square. You can see the power of 10 is the same. So it is essentially 4 square plus 2 square. The 10's power, you can take it outside. 4 square and 2 square together will give you root of 20 into 10 to the power minus 5. Root 20 is 2 raised to root 5. Very good. That's it. Very good, Sanjeet. Excellent. Moving ahead to the next question. Just simple vector addition and Pythagoras. Now this is going to be a slightly tricky question. Magnet is suspended at an angle of 30 to the magnetic meridian. It makes an angle of 45 with the horizontal. Then the actual dip is. This is a very interesting question. So Pranav, if you want to join the JE program, there is a link just in the description box below. Just go to Crash Course G 2022. Just click on that link. Everything is there. You can just join it. Everything is applied already. The batch has everything, all the details, you'll get it over there. Okay. So even if you have any doubts, you can contact me on my Instagram handle Shreyas_Vedantu. So what do you do now? Here, what I will say is this is your magnetic meridian. Then this is your geographical plane. That means here if you go to the geographical pole, and if you go in this direction, you go to the magnetic pole. There is an angle between them. The magnet is suspended at an angle of 30 degrees to the magnetic meridian, and it makes 45 degrees with the horizontal. Very interesting. So the needle is making 45 degrees with the horizontal. That means, okay, it's like this. This is 45 degrees. Good. And 45 degrees with the horizontal. Fair enough. Now, the magnet is suspended 30 degrees to magnetic meridian. Oh. So you are taking some random plane now. You are taking some random plane, not even geographical plane. Okay, let's say this is some random plane. And this is basically 30 degrees. The question is, what is the true dip angle? That is the true dip angle. That's what has been asked. So the best way to visualize is like this. Okay, forget about all this. I'll start from beginning, so that because I just made a small mistake when I drew the diagram. I'll just correct it over here. See this. The magnet is not suspended in the magnetic meridian. It is suspended in some other plane. That's the catch. So this is some random plane. This is where the needle is suspended. In that random plane, it is making 45 degrees. But the actual plane in which magnetic fields exist is this. Because if you go like that, you get the magnetic poles. Over here, this is the different plane, and that plane is making an angle of 30 degrees. Fair enough. Now, try to understand this over here. There are two components of Earth's field, horizontal and vertical. In this black random plane, there is a vertical component, BV, and there is also a horizontal component, BH. But this is not the true horizontal component. Think why? Because actually speaking, the Earth's magnetic field is in that direction, in this direction. So the magnetic field should be in that red plane. So truly speaking, the Earth's magnetic horizontal component is in this direction. This is just a component of that horizontal. Visualize this in that horizontal plane. Okay, in that horizontal plane, BH is this way. In this direction, you are just measuring the component of it, cos 30 component. So this is BH cos 30. Is that making sense to you? Is that making sense to you? Yep. Now, once you understand it, things will start making more sense. See, this 45 degrees can be written down like this by writing a trigonometric ratio. If I try to find out tan 45, which is opposite, which is BV, by adjacent, which is BH cos of 30, now I know what is BV by BH. BV by BH in general is your tan of true dip angle. True dip. This delta is your actual dip angle, BV by BH, in that magnetic plane. So just have to rearrange it. So this will become tan 45 is equal to tan of delta by cos of 30. So essentially tan delta will be, this is 1, cos 30 is root 3 by 2. So delta will be tan inverse of that. So tan inverse of root 3 by 2, which is option A. Perfect. Perfect. This is how it works. Is that okay? See, what has happened is, in that horizontal plane, try to understand this, there is Earth's horizontal component and there is vertical component. But the needle is not in that plane. The needle itself is in some other plane. It is in some other plane here. So this BH component is what I have chosen. So the component of BH will be BH cos 30. In that plane, this angle, which 45 degrees, will be this height, which is BV, by base, which is BH cos 30. That's it. Now I know BV by BH by definition is tan of the true dip angle. That's all. That's all. Okay. I hope this is clear. Fair enough. So that's the answer. Perfecto. Perfecto. Moving ahead to the next one. In the previous question, everything is fine, I think. Yeah. Oh. I think here there is a mistake. Thank you for pointing it out. Yeah, this should have been 10 to the power minus 5. Yes. Because this is 10 to the power minus 5. This is 10 to the power minus 5. This also should have been 10 to the power minus 5. Yep. Cool. Yes. Chalo, let's get moving to the next one. Oh, it's a time for break. I just give some rest for my throat. There are only 2 small chapters remaining. There are very interesting techniques, especially for AC, which I want to discuss with you. Shall we take a 10 minutes break? Yeah, shall we take a 10 minutes break? So Yoga Shimi, I'll tell you what. See, if you want to learn these chapters in detail, okay, still there is time. What you can do, we'll take a 10 minutes break, but before that, let me show you where and all you can find all these videos. So just go to playlist on our channel. Just go to playlist. When you go to playlist, right over here, do you see Pathfinder? Pathfinder is 2022. That means 12th standard. Click on this. Click on this. You will see all my classes over here. Just click on Pathfinder Physics playlist. Just click on this. Just go down over here. Do you see this playlist? Right over here? Yeah, look at this. This is the entire Pathfinder playlist. So go down a little bit. Go down. You can see capacitors, magnetic sources and all of that. And go down a little bit. Magnetism, Earth's magnetism. You can watch the detailed classes over here. All my classes are over here. So I have finished EMI, AC. In fact, I have started light waves also. So you can watch it all over here. That's something which you can do. Not just that, let me also show you one more interesting thing. If you feel that these questions are very easy, sir, I think I should be doing JEE questions. Even if you're watching the video right now, even now you can join our JEE, final crash course, which is very, very crucial, last leg of your preparation. Even if you have not so much idea about JEE, have not prepared up to the mark, but you need that boost to push yourself, then you can go ahead for that. That's your JEE crash course 2022. Okay, so for all the 12th standard students, you can just go ahead, you can check. It's just for 9,000 rupees. It has test series, it has live classes, it has recorded classes, It also will give you assignments, test series, report cards to compare your score with the previous year's toppers as well. So these are the things which you can explore. Meanwhile, that we take the break. So we'll take the break for 10 minutes. Okay, 10 minutes only. Let's return back. Okay. Achha, 15 minutes, all right. Chalo, we'll do that 15 minutes. No problems, guys. Let's do this break for 15 minutes. Okay, cool. Yes, you can join next week, Veera. Even if you join this week, let me tell you, you can choose to join next week. I mean, you can start attending from next week, and whatever you have missed, you will get recorded, or you can even join the batch which is starting next week. But the earlier you start, the better it is, because you will end it faster. You will push yourself and complete it. You will have a lot of time for revision. That's what I will tell you. Okay. Last 45 minutes class. Okay. So capacitance of a single conductor, Kirti Vasan, that is not there, bacha. What do you mean by single conductor? Acha, you mean like a sphere? So for a sphere, the capacitance is 4 pi epsilon naught r. You can think for a sphere, right? The other plate or the other conductor is at infinity. So even an isolated sphere is a capacitor because it will store charge. Just that the second conductor is at infinity. So there is field right from the sphere till infinity, and it is storing the energy in the space around it. That's how you can think of it. Okay, that's how it is. Is there an offer like term 2 plus JE? Yes. So when you join the pro subscription cyber piece, there is a link called as pro subscription. I don't know whether you have seen that below. So there is a link over here. So term 1 and 2. So there is crash course. You can see this. This is term 1 and 2. So when you join this, you will get term 1 and 2 preparation separate. But if you want just the pro courses, then what you can do is, let's say you go to grade 12th over here. This includes your CBSE plus your crash course. All of these two things together. Okay, you can join this pro course. So if you just want crash, then go for crash. If you just want CBSE, go for CBSE. That's all. Okay. Palimil, yes, you can join crash course after term 1, but that will be little too late. I would suggest join as soon as possible. You can watch the recordings even later on. The second batch is starting this week, Monday. This coming Monday. Okay, this coming Monday it will start. Okay. If you have not yet started preparing, yes, crash course will help you, because last year there are so many students who joined the crash course even after, not having done much. But once they got into the mood, they saw other students preparing, the teachers preparing, and also when they saw the assignments, then they got that moral boost and confidence. Then by second, third, fourth attempt, their scores started improving, and finally they got into NITs, and some of them even got into IITs. So even if you have zero knowledge, you can still join the crash course. It's okay. Yeah, the second batch will start, like I said, this coming Monday. Okay, chalo. I'll take a break and I'll see you in some time. Good evening, good evening, good evening, my lovely warriors. Well, I hope you had your chota mota lunch and welcome back to the session, marathon session. And those of you who are joining in late, this is a formula revision and application class. We discuss the formulas at the start of the chapter and then I do questions based on that. Yesterday I conducted another marathon that was assertion, reason and case studies along with NCERT underline. In case you have missed it, do watch it. And if you're a JEE student and aspiring for cracking JEE 2022 and you feel this is easy, and I would suggest go ahead, join the test series with our classes and the last leg of preparation, which is the JEE crash course. So welcome back all my warriors. So yes, I did not eat my lunch, but I had some random junk, not junk exactly, but yes, I had some bananas. Yep, that's what I did. Yep. I was watching your Women in Science video. Oh, glad Deepthi. I'm pretty sure you would have loved it and you would have enjoyed it. So Sanjit, I'll be having my lunch after this session is over. So let's get going. Hi Lalu, Aju, welcome aboard. Okay, so get your friends along. Make sure all your classmates, batchmates from your school, coaching, wherever they are on this session. The last leg of the preparation is going to start now. Okay, so time to begin. Okay. Okay, so yes, we have electromagnetic induction, right? Correct. So in EMI, what are the important formulas that we need to remember? We start with Faraday's law, of course. Let's write it down. So, and before Faraday's law, I think we should talk about magnetic flux. So if you have a coil or any area and let's say there are magnetic field lines passing through it, so the magnetic flux phi b is given by field into area, the dot product. The dot is nothing but cos. This is the field and the area vector is always perpendicular. Remember, the area vector is always perpendicular to that coil. Now if the flux changes, what does it do? That change in flux produces or induces electricity, and when you say electricity, obviously there will be EMF, and if there is some resistance given, you can also find some current. Okay, so what is the formula for induced EMF? That is given by Faraday's law. So Faraday's law just says that the magnitude of that EMF is d phi by dt, rate of change of flux, how quickly that flux changes in that given time. And Lenz's law just tells one thing, that the direction of this current which is created inside the coil, the current which is induced, has only one job. This current produces induced field to oppose change in flux. Just to give you an example, imagine this is a loop. Okay, this is a loop, and imagine the field is coming towards you. This is the field. Let's say this B is increasing. It is increasing. Then in this particular loop there will be induced current. The question is, what is the direction of the induced current? Hanishma, induced means like I'm inducing knowledge in you. I'm not touching you. I'm not like, yeah, okay, I'm going to bring you close and yeah, stand under me. I'm going to give you blessings and I'm not going to transfer my energy. It's like wireless transfer. So I'm just inducing. So a magnetic field wirelessly creates electricity in a coil. How? When you change the flux. I hope that makes sense. Yeah. Now the minus sign is there when you remove the mod. I'll just come to that once again. So field is increasing here. If field is increasing here, by Lenz's law, to oppose it, you will create a field inside. So the induced field. So the induced field should be inside, right? If the induced field is inside, hold your thumb, right hand thumb inside the plane of the board. See how your fingers curl. See how it is moving. So this will be the direction of the induced current. That's all. Now When you are, most of the problems, when you solve it, you are not going to be worried about the sign so much. You are generally be talking about the magnitude. But if you remove the mod symbol, then what happens? This EMF will become minus d phi by dt. This minus is significant for Lenz's law. So for Lenz's law, it is just saying that it opposes the change in the flux. That's all. Otherwise, mod value mein there is no d phi by dt. There is no minus sign. Fair enough. Everybody clear till this point? Very good. Now, when you take a rod and you move it in the magnetic field, then also there is EMF created. This is called as motional EMF. Motional EMF, and the motional EMF formula is BLV. So this is the motional EMF formula. This is something again which you should remember. Very good. Okay. Now, Hari, that's what I told you. This is how you find out directions using Lenz's law. As simple as this. Hari, just see where the field is increasing. Field was increasing here. That's it. Opposite. How do you oppose? Keep a thumb opposite to it. See how your fingers curl. That's it. That's the direction of the induced current. I'll give you one more example. Imagine there is a coil. Imagine there is a magnet. This is north, this is south. Okay. For example, okay, this is the axis. Okay, something like this. Now, let's say this bar magnet is moving this way. If that is the direction of the motion of the magnet, it will create some field. How will the field look like? It will look something like this. Correct? This is how the magnetic field will look like. Now, if you talk about this field, as this bar magnet comes closer, more and more lines will cut through that. So, do you see the flux is increasing in this direction? More field lines will come over here. So, by Lenz's law, the opposing field which is be induced, the opposing field which will be induced will be in this direction. Everybody agrees with that? It will be in this direction. So hold your thumb in that direction. See how your fingers curl. It will curl like this. So that's the direction of the induced current. Makes sense? Got it? Very good. Chalo. Moving ahead to the next part. There are only few things over here like inductors and all of that. So let me quickly tell you about it. So you have self-inductance and you have mutual inductance. So in self-inductance there is a coil, there is current. The own change in current causes opposition in the coil itself. So any changes in the current is opposed by the coil itself. In mutual inductance you have a primary coil and it affects the secondary coil. So you have primary and you have the secondary. That's the only difference. So there is some flux associated over here. That flux is Li. In this case, the field produced by this will cut through the other coil. Okay, it will cut through the other coil. This flux is Mi. M is mutual inductance, L is self-inductance. If you differentiate this, you will get EMF, which is minus d phi by dt, which will be nothing but minus L di by dt. Same thing over here. If you want to find the EMF in the secondary coil, just differentiate the flux over there. So it will give you minus M di by dt. As simple as that. That's something you should keep in mind. And energy stored in an inductor. So every coil, every loop has its own inductance. So any loop can be considered like an inductor. And the best example is a solenoid. Solenoid is an inductor. So the self-inductance of a solenoid is given by L is equal to mu naught area of cross section into N square into L. What is this L? Length. This turns per unit length. A, area of cross section. Similarly, if you take one solenoid and inside that you put another solenoid, then we will be talking about mutual inductance. So the mutual inductance between two coaxial solenoids M is given by same formula, mu naught area of cross section of the smaller coil into, instead of N square you will put N1 N2 into the length of the solenoid. N1 into N2. That's it. Instead of N square, you'll put N1 into N2. Very easy to remember. And energy stored is half Li square. Keep this in mind. Fair enough? Cool? Great. Chalo, let's get moving to the next one. I hope you have noted this down. Okay, you can take a screenshot also if you want to. All right, there we go. The only thing which is now remaining is if you take a coil, okay, let's say this is the axis of the coil and you rotate it with angular speed, and let's say this is the magnetic field, then the EMF which is induced in the coil. Why is EMF induced? Think over here, this is the area vector. The angle between them will change. So the flux will change. Because the flux changes, electricity is created. This is going to produce an AC wave. So this is an AC generator. So the formula for that is something which is very important. Induced EMF is born, BA omega n sine omega t. Very important formula. AC generator. Okay. K root L1 L2, which formula? I'm not sure, honey, which one you are talking about. In terms of magnetism, honey. Okay, cool. Now, very good. Chalo, let's get moving then. I don't think anything else is left. Let's start with the questions, I believe. Let's start with the questions. Okay. The back EMF induced in a coil when a current changes from 1 ampere to 0 in 1 millisecond is 5 volts. The self-inductance of the coil is how much? That's the question. How much is the self-inductance of the coil? Figure this out. Now the back EMF, that means the induced EMF is given and the current changes in this self-inductance. Which is the formula? I think you have to use minus L di by dt. Just use this. The EMF is 5 volts minus L. Change in the current from 1 to 0. So delta I will be minus 1. This will be minus 1 in how much time? In a time of 1 millisecond. So 10 to the power minus 3 seconds. Minus minus will cancel. So L will be 5 into 10 to the power minus 3 Henry. Is that the answer? Okay. Very good. Very good. Let's get moving to the next one. Perfect. Somebody was asking what is the difference between the behavior of an inductor in AC and DC. So an inductor in DC, okay, is like just a wire, whereas in AC circuits you will see an inductor will behave like a resistance. That resistance is called as inductive reactance. That is called as inductive reactance. So for AC, inductor provides some resistance. For DC, it is like a wire. That's something which you should know. Next, the magnetic flux linked with a coil is given by this equation. The induced EMF in the coil in the third second will be how much? Okay, very interesting. Just direct formula. Okay, direct. Let's do this. So EMF will be minus d phi by dt. The question is just the magnitude, I believe, but still. So minus d by dt of 5t square plus 2t plus 3, which is minus derivative of this will be 10t plus 2. So EMF at 3 seconds will be minus 10 into 3 plus 2, which is minus 32 volts. So I think we have just to find the magnitude of it. So the modulus of that will be just 32. Correct? So that's 32 units. Perfecto. Perfectos. So, this problem also tells us that, there are multiple ways of changing or creating EMF. See, flux is B A cos theta. Either you change B, or you change area, or you change theta. In this question, flux was changing because B was changing. Area can change if you change the shape and size, and this can change if you change the orientation. So any of these three things can cause flux change. Moving on to the next one. The current decays from 5 to 2 amperes in this much second of a coil. The EMF of the coil is this much. What is the mutual inductance of the coil? Very interesting. What's the mutual inductance? The current has changed. So I think because EMF is given, I will just use minus M delta I by delta T. The EMF is given to be 30. The mutual inductance, I don't know. Change in the current from 5 to 2. Final minus initial by the time 0.01. So this will become minus 3 and take this over there. So it will become 30 into 0.01 into m. Okay, and this will be also become minus 3, I believe. Yes, minus minus becomes plus. So m will become how much? 0.1 Henry. Just check this out. If it is correct, yes, option A should be correct. No, Naidu, it is not B, it should be option A. Yep, it is option A. Very good. Moving on to the next question coming up on your screen. There is a coil of inductance 40 Henry. It is connected in series. So the question is, what is the time constant if it is connected to the battery? What is the formula for time constant? Yesterday also I discussed this and today also it's coming. Time constant is L by R. Time constant is L by R. If you know this, that's it, your job is done. L is 40, R is 8, this is just 5. So answer is 5 seconds. Done, done. Time constant is L by R. So keep this in mind. For LR circuits, it is L by R. For RC circuits, it is RC. Just RC. That's it. Done. Very good. 5 seconds. Next question coming up on your screen. A coil having area A is placed in a field which changes from B to 4B. In time t, EMF will be how much? Very nice. So B has changed. So I think the induced EMF again using Faraday's law again. So let's use Faraday's law. So according to Faraday's law, EMF will be del phi by del t. Change in the flux will be final flux minus initial flux. So I think I can write it like this. Final flux, okay, so final flux minus initial flux upon the time taken. Final will be 4B naught into the area which is A naught minus initial flux will be B naught. There is minus sign also. If you want, you can put this right over here. So B naught into A naught, and this whole thing divided by time. How much is the time? T. So 4 minus 1, that's 3, and so you will get this as minus 3 B naught A naught divided by T. Is it there? Yes. So that's the magnitude of it. So you take the modulus. Just take the modulus. Got it? That's it. Just take the modulus. Don't worry about the minus sign. What have I told you about the minus sign? It is not so important for most of the problems. The minus sign just signifies the direction. So most of the times they are going to ask you magnitude. Next question. There is a coil which has so many turns. The question is, if it is rotated by 180, what is the value of induced EMF? Okay. Thank you, Samriddhi, so much. All right, let's get going. Yes, Suhani, obviously. Yesterday also I was teaching till almost 4:30, but today we'll be ending within next 15-20 minutes, not more than that. The coil has these many turns, this much is the area. Okay, so what is the induced EMF? So this is my logic. If the coil was facing like this and you turn it and then the area vector goes like this, okay, and the magnetic field was here, so obviously the flux has changed. How, you might ask? See, the initial flux, if it is BA cos 0, the final flux is BA cos 180. This is BA because cos 0 is 1. 180's cos is minus 1. So minus BA. So hence, when I try to calculate the EMF which is induced, which is del phi by del t, what I will just say, final minus initial. Oh, by the way, there is minus sign here. So minus final minus initial, which is again BA, but divided by time. What is the time? Okay, I'll just put it over here. And there is one more catch. There are 2000 turns. So I'll have to multiply this n times. In fact, over here also I need to multiply it n times because each turn will add to the flux. So just multiply it by n. So minus BA is minus 2BA. So minus minus becomes plus. So 2BAN divided by 2. Now just substitute, by T. So now just substitute the value. So 2 into field. What is the field? It is 0.3. What is the area? It is 70 into 10 to the power minus 4 into turns is 2000, which is 2 into 10 to the power 3. The whole thing divided by the time, 0.1 second. That's it. Just do the math and we'll get it. So 2 2s are 4, 7 3s are 21, 21 4s are 84. So it should be either A or B. Just check this out. Is it A or B? One of them. It's coming out to be B. Well, is it? Very good. Let's see if you guys are correct. Excellent. It is correct. Very good. Okay. Very good. Very good. Let's get moving to the next one. Wow, this is an interesting one. Many students will make a mistake. A jet plane is traveling west at a speed of this much. Voltage difference between the two ends is this. Having a wingspan of 20 meters. If the Earth's field is given and the dip angle is given, is how much? Okay, I'll tell you how to solve this. First of all, just imagine the plane. Okay, imagine this is the plane. It's going like this. Okay, this is the west direction. This is 20 meters. This whole thing is 20 meters. Now, the Earth will have magnetic field in the north-south direction, but I won't need the total magnetic field. What I need is only this component, because in that BLV, that B is this inside magnetic field. So to find out EMF, I need BLV. This B is this inside field. Now think carefully. You are looking at it from the top. There will be two components, right? There will be one horizontal component BH and there will be one vertical component. So this B which I need is BV. Is that understood? So I need BV over there. So how much will be BV? So we can just visualize it by a simple triangle. This is B, this is theta, this is BH, this is BV. So BV will be B sine theta. So hence you can see over here this is B sine theta into L into V. Now just solve the problem. Field is 5 into 10 to the power minus 4 sine of 30 degrees into length, how much? 20, and velocity which is 1600 but multiplied by 5 by 18. Now you will get the answer. Got it? Got it? Very good. So the whole idea is that here many students forget that the dip angle is there and they just use this field and then they don't know which component to choose. So whenever you have a rod, always choose the perpendicular component to the length. That is the field which will come. Yep, that's how it is. How cross? What do you mean by which cross? Okay, how BV is only taken? See Adit, that's what I just said. So whenever you have motional EMF problems, you would have seen this B is there. Correct? What is this field? This is the field which is perpendicular to the length and velocity, right? Now the plane is moving like this. This is the rod. This is the rod. Which is this component? You're looking at it from the top. The raindrop will fall like this. This is down. This is down. This, remember, is north. This is south. So this is the ground plane. So that is horizontal, that is vertical. So that's why I will take BV, which is the vertical component. Understood, Adit and others? And why 5 by 18? This is your kilometers per hour to meters per second. So how do you convert kilometers per hour into meters per second? You have done this conversion. 5 by 18 multiplied by 5 by 18, it will convert it into meters per second. Understood now? Perfect. Let's go ahead. Chalo. Thank you. Very good. Wow. Look at this. We have reached alternating current. Crazy. Let's do the questions. But before that, let's do the formulas. Now I'm going to tell you some interesting things over here. So pay attention. First of all, see, if you have AC circuit, what is this called? This is called max or peak value. You have something called as the RMS. Now the RMS is always the peak value by root 2. The meaning of RMS is that when you pass AC current through a resistor, it will develop some heat. What will it create? It will create some heat. This is AC. Now, when you want to find out how much heat is generated, okay, understanding AC might be difficult because the voltage is continuously changing. Current is also fluctuating. So, if I tell you one constant current, DC current, which is passed through the resistor and it develops the same heat, then you will get the feel of it. Acha, 5 amperes current is going. Then that current is called as the RMS current. So RMS current is the quantity of current which produces the same heat as that of the AC circuit. So it gives you a comparison. That's all. Okay, that's all. Cool. Now, apart from that, you should remember the transformer ka formula, AC transformer. I'll then go to the phasor diagrams and all of that. Hold on, I'm not skipping it. The transformer has one of these three roles: either to increase the voltage or to decrease the voltage, or sometimes it is also used to keep the voltage same, but just to create some kind of isolation. You want two circuits to be disconnected from each other. So that time also you can use it. So if you take primary turns as N1, this is called as the primary, this is secondary, you will see when you pass AC current over here, this AC current will create a magnetic field around it, definitely, and because the current changes, the B also changes, and that creates induced electricity in the secondary. So you will get secondary voltage. So if this is I1, this is V1, this is I2, this is V2, then remember simple formula N1 by N2, which is also called as the turns ratio. Turns ratio is V1 by V2, but current wise it is I2 by I1, something which you should know. It's inverse for current. Okay, keep this in mind. Very good, excellent. Now, apart from this, when we talk about LCR circuits, this is L, we'll solve this together. This is R, and you connect it to an AC source. Let's say this AC source is E. Let's say there is some current flowing through this. Let's say I call it I. Let's say this I is I0 sine omega t. This I0 sine omega t mein I0 is the maximum, omega is the frequency, angular frequency. Now, this is inductor, capacitor, resistor. Across the inductor, you will have some voltage. This is VL. Across capacitor, VC. Across resistor, VR. When you add all of them, you will get the total voltage E. When you add all of them. But you cannot just directly add them. This is one common mistake. So let me tell you, VR plus VC plus VL is not equal to E. Yes, it is not equal to E. The problem is the voltages are not in the same phase. So that makes, or that basically needs, to take the help of something called as the phasor diagram. Phasor diagram tells you when there are 2-3 more sinusoidal quantities which are varying with respect to each other, it helps you analyze those quantities in a much easier fashion. Very easy fashion, just like what you have studied in waves. So, for example, I tell you there is a phasor of current. Let's say this is the phasor of current, I0. That means if this arrow mark rotates, as it rotates, the height of it represents the instantaneous value. The height of it. So as it goes up, the instantaneous value increases. As it goes here, it decreases. So as this arrow mark rotates, the instantaneous values keep on fluctuating. So that phasor helps us understand those currents and voltages. Now, what happens is, in case of an AC circuit, the voltage across the resistor, is in the same phase. So VR is like this, meaning if this is the current, then voltage is also in the same phase. There is no shift between them. But for inductor and capacitor, there is a change. In fact, I told you, for inductor, it is always on the top. And the best way to remember is, love is above all. Love is above all. That means L, love. Yes, love is above all. So VL is on the top and VC, C is below. C is below. That's it. So voltage is ahead of current. Okay, by the way, if you are wondering which one is ahead or which one is behind, this is how it rotates. It all goes like that. So VL is ahead of current. Capacitor's voltage is behind the current by 90 degrees. Now it's just a matter of treating them like vectors. Yes. So when you add them like vectors, VR vector plus VC vector plus VL vector, then it is E vector. That's how you should understand. So if I tell you add these three forces, first you will get rid of these two forces. So what will you get? You will get this one as VL minus VC or VC minus VL, whichever is more. This force or this vector will come over here, and then you will find the resultant of these two. So how will the resultant of these two look like? The resultant of these two will be here. So this is your final vector, right? So this is how your final EMF is going to look like. So you might be wondering, sir, what is the magnitude of this EMF? Well, you can see it directly from here. It's Pythagoras. So strictly speaking, what is E? E is nothing but root of base square plus height square. So VR square plus VL minus VC whole square. As simple as that. Got it? Is it understood? It's so easy to remember. Now, once you're done with this, remember there is also some angle between them, that is the phase difference. Angle between the current and the voltage, what is it called? It is called the phase difference between the total voltage and current. There are different ways in which you can write it. Like for example, you can say cos phi is VR by E. VR by E is cos phi. You can also say tan phi. Tan phi is, see, look at this. This is the same angle. VL minus VC by VR. One and the same thing. Yep. Now, once you understand the voltages, understand the resistances also can be written down. Trust me on this. See, one thing you should see, that current is same across all of them. Voltages are different. Why is current same? Because it is in series. So, if somebody asks you what is the value of VR, you should quickly jump and tell VR will be I into R. Ohm's law, V is IR. If somebody asks you what is VC, VC is I into XC. VL will be I into XL. What is this X? Equivalent of resistance for capacitor and inductor. So XC is nothing but 1 by omega C. XC is 1 by omega into C, and XL, what is XL? It is just omega L. That's something which you should keep in mind. Inductance into frequency angular gives you the equivalent resistance of an inductor. Reciprocal of omega into C gives you equivalent resistance of a capacitor. So once you understand this, you can even draw a triangle for resistances. Look at this. You can draw resistance horizontally because VR is here. XL, you can draw it over here, and XC, you can draw it below. That's it. Now again, just like you did it over here, you take care of these two. So you will be just left with, I think, XL minus XC. If you subtract these two, the resultant of this and this vector, you will get the total effective resistance. That resistance is called as Z, which is impedance. That is called as impedance, nothing else. And this is your, again, the same angle. Now you can see, you can also write cos phi as, cos phi as base by hypotenuse. You can write tan phi as opposite by base, which is XL minus XC by R. So one and the same thing. If you know this vectors, you also know these vectors. Okay. Last thing. Just like I told you that voltages don't add, but they add like vectors. Same way, resistances don't add. They add like vectors again. Meaning, Z is not equal to R plus XL plus XC. Wrong. This is not true. In fact, Z is R vector plus XL vector plus XC vector. So strictly speaking, Z is root of root of this square plus this square. So it will be r square plus xl minus xc whole square. So do you see that if you treat these like vectors, it actually becomes easy. The meaning of impedance is the collective effective resistance of resistors and inductors together and capacitors together. Because inductor and capacitor also opposes AC, so their collective resistance is called as resistance. But then why don't you use the word resistance? Because only resistor loses energy, inductor and capacitor do not lose energy. That's the main difference between them. So we have given them different terms like reactance. Got it? Very good. Now, yeah, so leading and lagging. So you can see over here, everything is clear. EMF leads the current in this case. Capacitor's voltage lags behind the current. It is behind because voltage across the capacitor is behind the current. Current goes first, then comes voltage of capacitor. In case of inductor, voltage comes first, current goes later on. But in case of resistor, voltage and current are in sync, in phase. That's how it works. Got it? Fair enough. If XC is much larger than XL, then the entire Z and entire E will almost be here. It will almost be here. Cool. Now one last thing over here, the power. A lot of you need the power formula. So the power in a AC circuit is I squared R, or you can also use VI cos phi. Very important. This V is V RMS, this I is I RMS, and cos phi, that is also very important. This cos phi is called as the power factor. Power factor. Keep this in mind. Very good. Chalo. Let's start doing some questions then. I believe it's good time to start doing some questions. Okay. Hari, see, simple. Just look at this diagram, it's very obvious. If I tell you Laddu, Champu and Raidu, okay, this is Raidu, this is Laddu, this is Champu. All of them are going in circle like this. They are going in circle like this. Who comes first? If you wait here, Laddu comes first, resistor Raidu comes next, Chandu comes next. That's it. So look at it this way. Voltage is ahead of current. This voltage is behind of current. This voltage is with the current. This voltage is ahead of current. That's all. Very good. Now that we have spoken about all this, the last few things over here. See, again, when you have LCR circuits, this is your source. If somehow the source frequency is omega, you adjust the source frequency and you check what's the current in the circuit. Check what's the current in the circuit. Then, then this current graph looks somewhat like this. It becomes maximum somewhere. So it becomes max somewhere. When it becomes max, that is called as resonance. Meaning, not all frequencies are favorable or acceptable to this circuit. Some frequencies, they will resist more. But there is one particular frequency, they will accept it. That most accepted frequency, that's when the current is maximum. And when resonance occurs, what happens is the XL value and XC value will be equal. So the total impedance is just the resistance. Z is just R. Basically, what happens is the voltage and the current are in the same phase. The total EMF of the circuit and the current are in the same phase. Phi is 0. That's what happens during resonance. And this frequency is nothing but called as the natural frequency, and very simple formula, root LC. 1 by root LC is the natural frequency of that circuit. When it matches, then the impedance is just resistance. Power factor is 1 because angle is 0. XL and XC both cancel out each other. And why is it called as the natural frequency? Because if you take only inductor and capacitor and if you charge it, you will see the charge will go back and forth at exactly this frequency, which is the natural frequency of oscillation of the charges and the current in a LC circuit. So what happens is that if you force this circuit with an external source at the same frequency, it will vibrate, it will oscillate, it will take that current in a maximum value, and that's when it resonates. I hope this is clear. Cool. Let's solve some questions, and there are some interesting parameters over here like quality factor and bandwidth. So bandwidth is this over here. So bandwidth is over here. This is bandwidth. Bandwidth is the range of currents for which at least half the energy is transmitted. So all those frequencies for which at least half the energy goes in the circuit, is that range of frequencies over here is the bandwidth. And yep, the bandwidth formula is nothing but R by L. That's something which you should remember. Okay, very, very important. Cool. And yes, you should also remember the quality factor formula. So quality factor is natural frequency by that bandwidth. So if you take natural frequency and divide it with the bandwidth over here, so bandwidth delta W, okay, that will give you the quality factor. That's something which you can remember. Okay, now in your NCERT, they have given the bandwidth as 2 delta omega. Again, I don't know why they fancy this 2 so much, but understand, if you remember what is bandwidth, you don't have to remember whether it was 2, whether it was half or something else. What they have done, I'll tell you, in NCERT, this is like this. This is the natural frequency maximum current. These are the 2 points where you get at least half power. What they have done, this they have taken delta omega, this they have taken delta omega, and then collectively bandwidth will be 2 del omega. Why do you want to do that? Just say bandwidth is del omega, yaar, simple. Why do you want to write half separate? It's easy, okay? So don't have to remember it 2 times and all that. Okay, as simple as that. Cool, let's do some questions based on AC now. Here is the first one. The equation of a AC voltage is this much. What is the average and the frequency? So Sriji, I'll tell you what is the gist about LC oscillation. Simple way to remember. You remember spring and mass, just remember that. That's it. Then you'll also remember L and C oscillation. This is L, this is C. Instead of spring, you put 1 by C. Instead of mass, you put inductor. You get everything as the same thing. Time period is 2 pi under root M by K. Here it is time period is 2 pi under root. Instead of mass, you put L. Instead of K, you put 1 by C, which is 2 pi under root of LC. So here the position changes, right? The position changes. Here the charge changes, and when position changes there is velocity. Here rate of flow of charge, you have current. So wherever you find x, put q. Wherever you find velocity, put current. They are all very similar. If you understand that, that's it. You don't have to remember it specially. So a charge capacitor will get discharged. It will pass on the current like this. Once it is discharged, again it will get charged. Again it will discharge, again it will get charged. That's what keeps on happening. Here the mass keeps on going, the x keeps on changing up and down. That's the only simple way of remembering it. Cool? Chalo. Let's see this question. Many of you have said option C is correct, but I have a feeling that most of you are wrong. Okay, if angular frequency is applied on the inductance, instantaneous power will be the angular. I'm not sure what you're saying. Can you be little bit more specific? Well, meanwhile, the answer for this is not C, it is actually A. You please read the question carefully. See, what does it say? Average value. This is AC voltage. So it goes up, goes down, goes up, goes down. What is the average? The average is this. This is the average. And the average will be 0. What are you guys doing? And this 100 pi is omega. Omega is 2 pi f. So f will be 100 pi by 2 pi, which is 50. So that's why this 50 is there. Be careful. Be careful. Average is 0. This 70.7, what you guys are saying, is actually the RMS value. 100 by root 2. Be careful. Got it? Understood? Yes? Let's go ahead to the next one. The next one is output of a step-down transformer is 24 when connected to a bulb of 12 watts. What is the value of the peak current? So essentially you have taken a bulb, okay, of 12 watts and you have to pass some current. The voltage is 24 volts. What's the peak current? Now just simply use power is V into I. Power is V into I. Now when you do this, what is this? Power is 12, voltage is 24 into current. Current will be half, which is basically 0.5. Now most of you will be looking at the options and you'll be like, sir, the answer is not there. So read the question carefully. This is peak. The question is asking peak current. This current which you have found out is just RMS value. Yes, when nothing is mentioned, everything is RMS. Even this is just RMS value. So once you know RMS, you can find the peak, because peak by root 2 is RMS. So basically the peak value will be root 2 by 2, which is 1 by root 2. Hence option A will be correct. Yeah, not B, it is A. Be careful, you made a calculation mistake if you got it as B. Understood? So when nothing is mentioned, it is always RMS. What is the relationship between IRMS and I average? See, average value of any AC circuit, right, is always 0. Whatever is positive is negative, whatever is positive is negative. Understand? So it is always going to be 0. Be careful. Okay? So RMS will be maximum by root 2. Average will be always 0 if positive and negatives are equal. Moving ahead. R is given, L is given, C is given, omega is given. Find the impedance of the circuit. Find the impedance of the circuit. Let's see how many of you can do this. Okay, so what do we have? Okay, so I think to find impedance we need R. We also need XL minus XC. Only then I can find impedance. How do I find XL and XC? Well, XL I just gave you, it is omega L. Omega is 10 to the power 3, L is 0.9, that means it is 900. XC is nothing but 1 by omega C, which means it is 1 by 10 to the power 3 into capacitance. How much is it? 2 microfarad. So 2 into 10 to the power minus 6. So this will be how much? 1000 divided by 2, which is 500. Okay, fair enough. Now look at the triangle. XL minus XC. XL minus XC will be nothing but 900 minus 500, which is 400. Resistance. Resistance is 300. So just mark this as 300. Question says, what is the impedance? Pythagoras, that's it. This is 400, this is 300. How much will Z be? Obviously root of 400 square plus 300 square, which is root of 500 square, which is 500 ohms. That's it. So where is it? Option C. Done. Very good. How omega is 10 to the power 3? Because 1000, my dear warriors, is 10 to the power 3. That's why omega is 10 to the power 3. Okay, CB? Yeah, 3 zeros. You can count 3 zeros. 1, 2, 3. So that's why 10 to the power 3. Moving ahead to the next one. Okay. In a series LCR circuit, R is this much, impedance is this much, then the phase difference between the current and the voltage is how much? Let's see how to do it. Is it okay to, if you study all the formulas? Obviously, BN gamers, you have to study all the formulas. How else will you do it? That's why I'm conducting this session. Why do you think I'm wasting my time here? No, right? So you have to learn all the formulas and also learn how to apply it. That's what we are doing here. So again, construct our standard triangle. This is R, this is XL minus XC, this is Z, this is phi. If you remember, Z was always in the direction of EMF. This was current. This is how it was. I think you can make use of some trigonometric ratio, most likely cos of phi. Cos phi will be R by Z. So R is how much? 10. Z is 20. So it is half. So whose cos is half. Obviously it is 60. Where is it? 60. Yep. Cos 60. Yep. Option A. There you go. Perfecto. Perfecto. Excellent. Moving ahead to the next question. In a step-up transformer, the ratio of turns primary to secondary is 1:10. Primary voltage is 230. The load current is 2. Then the current in the primary is. So if you are getting confused, always draw a diagram. It helps a lot. So this is our transformer. The ratio is 1:10. The current in the primary is 2 amperes. The question is, what is the current in the secondary? I think I just told you that the turns ratio is inverse to the current. So it will be primary by secondary will be secondary by primary. Okay. So secondary, I don't know, primary is 2, so 1/10. Okay, that's what is asked. Oops, sorry. The current in the primary is asked. I'm so sorry. I made a mistake over here. So sorry. The current in the primary was asked. Current in the primary was asked. The current in the load, that means this is 2 amperes. Yep. Now let's do this again. Turns ratio, primary by secondary is secondary by primary. So secondary is 2, primary is I don't know, this is 1/10. So IP is 2 into 10, which is 20 amperes. So 20 amperes is right over here. That's it. Very good. Yes. So primary current is what is asked. The load current. Load also means secondary. Okay. This is where it is generation side. This is the load side. It is generated, it is converted. So what is the use of this? There is no use of this. It's just waste. Yeah. That's all. Cool. Moving ahead to the next one. Resonant frequency is given, is asked, and the L values, C values and R values are given. Come on. Let's see how many of you can do this question really quick. Come on, my warriors, figure this out. What do you think is the resonant frequency of this circuit? First of all, what's the formula for resonant frequency? This is all in hertz, right? So remember, time period was nothing but 2 pi under root m by k. Instead of mass you put L, instead of k you put 1 by c. So frequency will be 1 by 2 pi root of LC. Oh, so just substitute everything. So 2 pi root of L. L is 2, C is 32 into 10 to the power minus 6 because it is micro. What about resistor? It is not needed. It's just given, time pass, ignore it. 32 into 2, 64. Root of 64, what is it? Root of 64 is 8. Root of 10 to the power minus 6 is 10 to the power minus 3. Correct? And oops, I think I had to put pi over here. So 2 pi. Yeah. So that's it. So take 10 to the power 3 there. So 10 to the power 3 divided by 16 pi. Yep. So calculate this. How much is it coming out to be approximately? Let's calculate this. How much is it coming out? Yeah. Not 1 by root LC. The 2 pi is important. Understand? Frequency means F. Angular frequency means omega. Frequency is 1 by 2 pi root LC. Omega is 1 by root LC. So see what has been asked and check the units also. It is hertz. So be careful. A for sure. Let's figure out whether you guys are correct. Yes, you guys are correct. Wow. What an amazing session it has been. I congratulate you to complete this session because you have completed this successfully. You have been attentive, you have been solving, you have been very involved in this session. Now the next step is not just, your board examination. The next step is, your JEE examination, your KVPY examination, your JEE advanced examination, your BITSAT examination, and you cannot start preparing for JEE in the last month. You have to start it now. The batches are starting this week and even the next week. In fact, there is a batch which has just started the last week. You can still watch the recordings right on your mobile phone or even on your laptop. That's your JEE crash course. Yep. All of you are asking, sir, what is this JEE crash course? This is a full syllabus revision for JEE 2022 aspirants with 90 classes, which will be also given to you as recordings. Also, there will be 10 full syllabus tests, 10 part syllabus tests. You can compare your ranks and your percentages with the toppers, which is very important because you cannot just keep on giving tests and then there is no use. You don't know where you stand. Also, you get access to the Doubt app. Not just that, you also will get the notes, you will get assignments after every class. You have such a big question bank to solve that you will have so much practice, and before your JEE mains you will be very, very well prepared. Who should join the crash course? All those students who are not happy or not so satisfied with their current coaching, or those students who have not yet started complete preparation for the JEE exam, or those students who are prepared but feel that they need some additional practice material and additional test series. So all those students should join this, and guess what? The price is just not 20,000, not 10,000, it is 9,000 rupees on a limited time offer. That offer can change anytime. Don't ask me later on, sir, the price became 10,000 or 20,000. So what you need to do is just go down. Here you can see JEE crash course. Just click on this. There you get JEE crash course. Just click on this. You have two versions, light and classic. Don't choose light because even when you choose classic, the price is same. What is the advantage? You will get doubt solving on the mobile app. That's the advantage. So you can click on this and say buy complete course, enter your phone or email ID. That's it. So make sure that you use this coupon code, because if you use this coupon code, then only you will be able to get my support if anything goes wrong or if you are facing any issues. So make sure you use that. Alright. There is another option for those of you who want to continue your preparation for CBSE only. No problem. Then you have CBSE Term 1 and 2 preparation made for you. Click on this link, that will help you. If you want more courses, like for example KVPY crash course, you can see KVPY crash course is available just for 1,800 rupees. Hardly 30-20 days are there for your KVPY examination, 1 month. So watch these classes, get your assignments and do your analysis. This is for KVPY SX examination. 1,800, it's pretty cheap. So try all these things out. It's up to you where you want to enroll yourself or where you want to invest your time. Yep. So first of all, thank you for attending, and thank you for all the love and likes that you have given on the bottom. Thank you so much. Thank you so much, Ibn. Take care. Have a great time. Make sure you have subscribed. Make sure you recommend the channel, and make sure you can also follow me over here on Instagram. Now tomorrow I'm going to meet you at 11 o'clock, but it's not going to be a big session. It's just problem. Are you ready? Are you going to be there? Yeah. So I'm hoping to see all of you tomorrow. Prepare well, revise now. Tomorrow I will leave you before 1 or 1:30. Okay, from 11 we'll start till 1:30 we'll wind up the session. Yeah. So after this session, I want you to go through the sheets and solve more problems from exemplar, from NCERT back exercise, sample papers, MTG or OSWAL, or even the PDFs which I have uploaded on the Telegram channels, and also go through the formulas today. Tomorrow it's just problem solving. Don't sit and remember formulas tomorrow. Tomorrow is a day only for problems. That's how I have planned these sessions. Okay. Okay, chalo. I'll eat my lunch now. I'm also very tired. I don't know whether my energy looks down or up, but I have tried to do my best. So please make sure you shower your love out there. It means a lot for me. Okay. Chalo. Signing off. Take care. Hasta la vista. This was Capto Shreyas.